please just hold tight. We'll get started as soon as we can. We're good to go? Perfect. All right. Damn, we did well. All right on time, guys. So today we have Brandon Lewis here. Brandon is going to talk to us about the art of creative coding. Brandon has been developing software for about 20 years and is currently a senior manager of software engineering at one of Perth's largest mutuals. He's presented previously at DDD, and his previous chat was around uses of blockchain outside of cryptocurrency. Today, he'll be exploring the question, can code create art? Over to you.
Oh, thanks very much. Wow, it's a good turnout. Thank you very much for coming. Really appreciate you taking the time. Before we start, I just want to thank the sponsors for DDD Perth. Without their generous support, this event wouldn't be possible. So thank you very much for that. Today, what I really want to do is I have three objectives. I'm hoping to sort of inspire all of you to try your hand at creative art, or generative art, and create code, or create art with code. I'm going to show you some of the tools that you might be able to use to do this, and some techniques, some basic techniques to sort of get you started. What you shouldn't expect is a maths masterclass. So while there are some relationships between mathematics and creative coding, I'm still very much a student of maths, more so than a teacher. So don't expect any math secrets, to be honest. And Web3 and NFTs, big topics, of course. Don't expect to learn how to get rich off Dogecoin, or with Dogecoin selling profile pics. That's not what we're here for. A bit about me. I've been developing commercial software for about 20 years. I've been coding for closer to 30 at this point. I've worked across the entire software stack, from front end to back end and everything in between. I specialized in integration for many, many years before moving into leadership roles and proceeding with that as my career. Currently, I'm a software engineering manager at a large WA-based mutual, where I lead a bunch of awesome people to do cool stuff, and I support them in being awesome. You can find me on all of the various Twitters and LinkedIns and whatnot, and I blog about leadership in my blog at leaderkaizen.com. Of course, being a leader, I don't really code all that much anymore in my work day to day, so I have to get my coding kicks elsewhere. And to do that, I usually create my own projects and work on things on the side in my spare time. That's sort of how I came to get involved with Unity and learn Unity and develop game prototypes with it. I really enjoy understanding how those processes and mechanics work and seeing if I can create them myself. It's a good learning experience and keeps my skills current, I suppose. It's also how I got into shaders. So from Unity and learning mechanics and developing those things, I got into shader development, which is really another gateway to creative coding and how I got into that. Some of the examples of shaders I've created are things like some emissive shaders for lava, obscuring objects that are obscured and doing outlines and messing with things like Z-buffer and whatnot to fake transparency and the like, and some ripples and whatnot. But of course, I haven't actually finished a game, and this tweet kind of explains why. That's kind of that explains me, really. But it turns out that my first experience with creative coding was actually many, many years ago. When I was about 9 years old, I joined a computer club, with all the cool kids did, right? And got introduced to Logo. With Logo, you move a turtle around and draw images on the screen, and it's actually used to promote software literacy and develop skills at a low level. I didn't realize at the time, of course, but it was fun, I suppose. And what I'd like to actually do is maybe share some of the things that you could do with Logo, because that's pretty cool. Of course, this is a Logo interpreter developed in JS and JavaScript. available freely and online. I'll have links and resources at the end of the presentation. But of course, being 9, this is kind of what I created, right? Like as you would draw on a piece of paper. And of course, when your skills are limited and you don't really know what you're doing, you kind of just chaos, right? Just chaos. And just create all sorts of random stuff that you think looks cool. But it wasn't until recently that I realized you could actually do some pretty cool things, like some depictions of mathematical algorithms in Logo itself, and I thought that was pretty cool. So this is an example of phyllotaxis, which is it is the way that leaves grow on stems and plants. So it's a biology thing, which is tied to can be represented mathematically, and thus depicted in code. And I thought that was pretty cool. Oops. Sorry, technical issues. Real technical issues. Cool. So, technology has evolved obviously since Logo, and the ability to create such stuff is a lot more accessible and a lot easier to do, particularly with things available on the web. Like you just saw, I could do Logo with through a browser, which is really cool. But today I'm going to be showing you P5JS and ShaderToy, which are 2 tools that create art in very different ways. And I'm going to sort of speak through how those differ. But both tools are web-based, both are freely available, don't require any subscriptions or any payments, and you don't even have to create an account on any of the sites. You can just kind of use them. There are comparisons that you can draw between creative code or art generated through code and traditional art. And I like to view them as the programs that you use, or the apps that you use, very much the mediums, much like canvases and stone and wood, where they determine largely the thing you're going to create. So you don't create a sculpture with a canvas, for example, and you can sort of view tools in the same sort of vein. And then the algorithms and the methods that you use to create these things, the code that you create, that's your brushes and your pens and your chisels. And so I'm going to talk through some of those today as we work through some of the demos. Generative art is, I think, and I'll sort of take a small tangent here and speak of NFTs like I wasn't going to do, but I genuinely think that generative art is a real, genuine use case for NFTs. Packaging the code along with the parameters to create the thing, I think, is very valuable, and I think is a real benefit and a genuine use case for NFTs. Processing with P5JS. So P5JS is the first of the tools I'm going to speak to you about today. And it's based on processing. It's a flavor of processing. And processing was developed in, I think, 2001 as a software literacy tool. It's a Java-based graphics library and IDE that you can draw stuff with. It is highly powerful, and it's used for things like simulations as well. So it's got a breadth everywhere from sort of beginner level access to very high level. But P5JS is a web implementation of that, as the name suggests, leveraging JavaScript. It does have a web editor, or you can build your own, which I think is pretty nifty. As mentioned, it's really easy to use, really easy to get into, and it's reasonably well documented. There are enough similarities, while not a direct one-to-one port of processing. The similarities are close enough that you could actually leverage the documentation in tandem. It is, I consider, sort of a high-level language. It abstracts a lot of the difficulty and complexity in creating some of this stuff quite well. So, for example, you can draw a circle, or you can draw a square, or if you're in 3D, a cube or a sphere. And you also use vectors, and vectors is kind of, we'll touch on some of those in a bit. But having that control really expands the possibilities that you have. And it's a bit more, like I say, a bit more high level than shaders that we'll touch on a bit later. You can, like I say, do 2D and 3D stuff. So we'll speak through some of those as well. To give you an example, these are all created with P5.js. So as you can see, very different in style, very different in nature, and I can speak particularly for the one on the right. That took a lot of time and a lot of effort. It's really interesting how that came about, and the author, or the artist, posted a really good blog post on that, which I'll share in the slide deck as well. That they talk about how they actually created it, and it's fascinating to see that actually come to life and come to fruition. Long process, took many months. And of course you can create animations, and I think that's one of the strongest draws of this in terms of comparisons with traditional art, and it's something I think we as developers, as coders, have an advantage in. We can create some really cool animations with things like P5.js and Shader Toy. So let's get on to some demos, right? Sans the technical difficulties. There we go. Close that one. So P5.js, you can go to a built-in editor. Like I said, super simple. If you want to create a circle and we'll do it in the middle of the screen. So width divided by 2, height divided by 2. If I could type, that'd be great. And 50. And it's a radius of 50, or a diameter of 50. And you create a circle. Super easy. You change the color of the circle, so change the fill to, I don't know, red maybe, because red. Yeah. Red. So super easy to use, and I think that's one of the biggest draws in terms of getting into it and just getting into creative art and trying to learn how to think creatively rather than problem solve. It's a really easy barrier, really low barrier to entry. But you can also create things like this, right? And this is an example of something I created with, in collaboration with the guys at MakerX, when trying to, I suppose, depict or visualize earthquakes in an interesting fashion. And we use kind of the number of circles that it would generate as the magnitude, so we'd reflect those, and then plot them randomly or perhaps in a geographical location and align that like that. But what's really interesting is that there aren't any circles here. These are actually created just by creating tangents at regular intervals and drawing a line. And this is, I think, where the real power, where you start to see the real power of something like P5.js, where you can use vectors to project these things, which are much more difficult to do if you have to roll it yourself. So what I actually do here is I take a point in a circle, I project a vector on one direction, add it to the other side, and then draw a line between the two. And I just do that for everything for 360 times, and it kind of draws a circle. And I'll loop through all number of circles. So it's still relatively simple to do. I'm not using any advanced mathematics. It's basic high school maths. And it creates some really interesting stuff. But of course, you can just keep creating new versions over and over. Or you could perhaps not even make it random. And you could take the circle out and have it depicted elsewhere. The creative part, and this is where it gets super interesting, is you start off with something like this with a simple idea, and then you try to expand upon it, and you could perhaps create something a bit more like this. And this is completely different in many ways to the other, but the code is almost identical. But what I do here is, instead of creating 360 lines to create a circle, I make them random, and I give them all different colors at different points, and just draw a number of them, and vary the alpha randomly as well. So you get this sort of stringy sort of look. And of course, if I was to remove the seed, you can create and create and create all sorts of different images. And of course, you can constrain them. So I'm not really doing anything to limit where those things appear, but you can sort of do that, and we'll get to some examples that do that in a tick. But you can do something that's more structured, perhaps, and something that perhaps even mimics real-life art, so like you're painting or something like that. And this is an example that I pulled together where I took a cityscape, a city skyline as inspiration. And I started off quite simply, where I just had true and false. I started out like that. And one of the things I really wanted to experiment with was layering. Layering on top of it to create this perspective and adjusting the alpha at various levels to give that sort of perspective. But then, of course, that evolution comes into play, and you're like, well, I want to try play with Bezier curves, and so I added clouds as Bezier curves. Bezier curves, again, another example of how P5JS makes something that could be quite mathematically complex if you wanted it to be. It doesn't have to be, mind you, but it can be. And makes it really simple. It's a simple function to create it. Down here somewhere. Bezier. So I kind of created those, but then I thought, well, what if I wanted to make it look like a paintbrush instead of something that's solid like that? I mean, that all was cool and stuff, but I mean, why not? This takes a bit of time. Why not create a paintbrush? And the way I did that was, now there isn't a paintbrush. You can't say, hey, P5JS, draw me a paintbrush, or draw this in a paintbrush stroke pattern. You have to create this manually, and that's easy. You take the square and you take the pixels and you just do one pixel at a time, and that's sort of why it takes a bit longer to do. And we'll get into how this is where one of the key differentiators between this and Shader Toy that we'll talk about later sort of comes into play. And then I thought, well, that doesn't really look brush-like, right? So you don't get the brush stroke at the end, and I wanted to just get brush strokes. So I added a little randomness to the length of each stroke. So each line is going up in a single pattern, and I'm just randomizing the height of that line each time to create a sort of brush stroke. And the palettes, I mean, you might have noticed that I have palettes or different palettes for everything, and that's just a list of JSON. JSON hex values, and I'll load them in, and then randomly pick one. That's as simple as it gets, really. Speaking of Bezier curves, I think Bezier curves are a beautiful illustration of maths. They're really simple in nature, but they can make some incredibly interesting shapes. And I sort of took inspiration here from the old Windows screensavers and sort of kind of bouncing around. That was the inspiration, right? And I haven't colored any of these, and that's I think the next phase is sort of what do you do with these to want to extend them. So you take something that's really simple in just 40 lines of code, and you can create all sorts of different shapes. And you start to your creative part takes over, and you're like, well, what can we do with that? For this particular instance, I sort of took one Bezier curve and then just linked it to another one. But what if you made that random in some way? Or what if you had that deterministic in some other fashion? What if you added color? What if you added different shading to the different lines? Then you start to get some art, right? Noise. So speaking of randomness, there is a lot of randomness in creative code, and there's a few different ways you can approach that, right? And you can have it as either completely random between two values, and it'll pick something. But sometimes you need something a bit more nuanced, a bit more subtle, right? And noise is a great way to do that. Something like Perlin noise, for example, where it's a gradient of randomness. It's something you can use when you want something like this, where you're only incrementing a value by a small amount from the last value every time, and you sort of iterate over that map, over that Perlin noise, and adjust the value accordingly. Very, very powerful. Again, something that is natively built into P5.js. So, speaking of rules, I mentioned rules earlier where you want to sort of constrain stuff, and I suppose this is more sort of software engineering-y, developer-y type of stuff. But you could constrain stuff like circle packing, and you could say, well, don't have any circles overlap, don't create circles in another circle, and create some interesting patterns. And you can then extend that again, evolutionary. Well, what can you do with that? Perhaps you have that in certain shapes. You could have that along a Bezier curve. So you have a Bezier curve and have the circles all pack along that curve within a certain radius and create lines like that. Or maybe you just want to represent Doge, right? Because why not? And this is a really cool example of just taking an image, sampling the pixel of where your point is, and then making the color of that circle that pixel color. And you can create something like this. And of course, you can adjust all of the values, and you can have circles be bigger or smaller. And you can. I did have to make some changes to this to make the image a bit more legible, because if you have massive circles, you then start to have huge circles of one color, and you can't really get that definition. You don't really tell what it is. So I had to implement something which would grow it and then slow it down as it got bigger. So as the circle got bigger, I would slow the growth down so that it wouldn't really go past much a certain size, and it would give time for more circles to fill in and pack it. And an example of phylotaxis again, so much like the logo example I shared earlier, but this time with nice pretty colors. And I wanted to show this purely because I want to show that the maths around it is super, super simple. And I think this is something which initially I found daunting when looking at creative code. I would see all these things on Twitter, all these things on LinkedIn, be like, that looks really cool, but I'm sure that's really difficult to do. And it's when you start to really dig into it, and you even just look up you go into Wikipedia and you look up what some of these equations look like, and they're not difficult, but they can create some really, really interesting patterns. Taking that a step further, and you can create images like that. That is the same pattern, just I'm now adjusting the size of each of the circles, and I'm coloring it a bit differently. That's really it. It's the same code, just a bit different. Same, but different. But it doesn't have to be all geometric. You can make stuff that's really random, really interesting, and almost paint-like. And this, I tried to replicate or reproduce a Jackson Pollock painting. So with lots of just sort of paint everywhere in arbitrary ways. And this is sort of what it comes up with. But of course, the benefit being code is you can create as many as you want. And you can tell that they're all slightly different in terms of brush sizes, and that's all determined by the code. So I could limit it to certain brush sizes or brushes, or I could make it go wild. Patterns, and you can introduce patterns to it. And there's a really interesting article I read about taking an image and using the values of those images, the color values of those images, to manipulate how the lines are drawn. So you end up having something that looks like this, but it has structure within it. And I thought that was really, really interesting. But this is really this particular example is the technique I really wanted to go in depth with a bit more, because you look at it and you can't. It might be difficult to see what's going on or how you create that. But when I found out how to create this, I was amazed how easy it actually was. And it's all very, very logical. And it's easy to demonstrate as well. So you take a look at something like this, and all it is it's a flow field, but it's created with vectors, which I mentioned earlier, which again, benefit of P5.js. But that's what it looks like. So you take a grid, you take a canvas, you plot it into grids, and you can adjust the size of the grid as much as you want. You then plot some Perlin noise over that, and then take vectors based on that Perlin noise. So if your noise is 0 to 1, and you relate that to a radius or to a direction, you then direct the vector in that way. And because Perlin noise is progressive, you start to get this sort of feel, this motion, as you will. So it's sort of like forces being applied. And all of the directions that you see here are just the directions of the flow field influenced by Perlin noise. And you can create, of course, I think I've got this randomized, I think, maybe, possibly. Yeah. I do like that seed. Oh, is it going to create the same one over? Yeah, but I can take a better seed. How's that? Oops. I mean, you can put in any seed, really. Now, I will confess there is a bit of a bug in it, and you'll see occasionally, you can see it here, where on the edges it sort of gets trapped between two. So again, you get to do some problem solving as an engineer, and figure out, well, how do you adjust the force or the direction of those so that you don't end up having these infinite loops on either side. But of course, it can be adjusted even further. So if you wanted to, for example, have it go longer. So right now I'm constraining the time, so it only has a certain amount of time to create. And that's probably something I should have called out. It's the alpha that makes it do that. So it's like putting a whole bunch of pixels onto the screen, and then adjusting the alpha gradually over time as you throw in more pixels. And those pixels kind of travel around, and as they leave more trails, you start to get thicker lines in the areas that they travel. But it's the vector, at the heart of it, it's the vectors that really help to make this possible. But again, super easy, right? There is nothing that should stop anyone, even someone with very limited development experience or programming experience, to do this sort of stuff. So I'd highly recommend people try it out. Cool. And then, no. Yes. Cool. So P5.js, in summary, is a fantastic tool for pretty much anyone to get into creative code. It's easy to get into. It's well documented. But it's also a really good tool for anyone with advanced programming experience. And the reason I say that is because I've only just scratched the surface. There is a breadth of capability there which you can leverage. I didn't even touch on the 3D stuff that you can do, but you can do 3D, and it does support shaders, for example, and you can hook it up to all sorts of other sources. And it's fantastic for kids. If Logo was what we were taught sort of 30 years ago, this is what kids should be taught now, in my view. Extra benefit, the skills are transferable. So JS, you can transfer that. Shaders. Shaders with Shader Toy. So, as I mentioned earlier, I got into Unity, and that introduced me to shaders. And shaders are a C-like-ish language, or use a C-like language, like GLSL and HLSL. They are high-level languages, but I would liken them to lower-level languages than, say, P5.js, in that they are assembly-like. It's not assembly by any means, but the way you have to think about working with them is very much assembly-like. They're used in the graphics render pipeline for 3D stuff, and used for things like lighting, shadows, reflections, all that kind of thing. There are several different types of shaders, by the way. So vertex shaders, geometry shaders, and fragment shaders, they all do different things. We're going to focus primarily on fragment shaders today. And what's really interesting is these are some examples that were created. There isn't any 3D geometry in there. There are no triangles, there are no meshes, there are no quads, no vertices whatsoever. That's all effectively drawn to the screen. And a call out to Inio Quiles, who did the rainforest. He's got a fantastic YouTube video on how he made that. Absolutely worth a watch. And we'll get on to some more demos. shader toy. Before I get too far in, I just want to give a quick sort of shakedown of what shaders are. In a typical 3D environment, you have a mesh that's made up of vertices and some lines between them, creating triangles. Then you can apply a material to it, but of course the material doesn't have any value until you apply some light to it. So you get some light and you get a material. You can then also provide some directional lighting and some shading on the material. It's all of the material stuff is the shadery bits, is that we're going to be talking about. So we're not going to worry about the vertices today. We're just going to be talking about the shaders. Sorry, about the fragment shader. I'm going to skip these examples because we're running low on time, but head over to Shader Toy to check those out because they're really, really interesting. But the thing I really wanted to, the method or the technique I wanted to share with you with regards to shaders is ray marching. That is how those images were done. And it's a really interesting technique to apply to creative coding in general. And you can use that to create proper scenes, or you can create fractals and all sorts of interesting stuff with them. And the whole notion of it is effectively looking at a scene and measuring the distance between the camera and something in the scene, figuring out what's closer and rendering that. And you render it pixel by pixel. I think that's the key thing to bear in mind with shaders, is you are not actually saying, hey, draw me a circle, draw me a square, draw me a cube. You are saying, I want this color pixel at coordinate XY to be this color. And that is all very mathematically, or can be very mathematically intensive. So it's a bit more daunting to get into, and we'll get into that a little bit. But ray marching is a process of determining the distance between objects in the scene and your camera. So I created this little sort of demo thing to sort of show how that might work. And I'm going to turn off all those. So say you started off with your camera in the middle of the scene, and we have a ray that's going out from the scene. Now say you add some objects into the scene, right? You want to try and figure out so if I'm looking in this direction, what am I supposed to render to the screen? I'm supposed to render number 1 at this particular pixel. So how do we do that? Well, we draw lines. We go through, we loop through the entire area, entire scene, and say, well, how far are you? How far are you? How far are you? And you try to draw the close. But you don't want to draw it to the origin of that. You want to draw it to the origin of the surface of that. And that's where stuff gets interesting, because that uses sign distance fields to calculate where the surface of it is based on what the center or the origin is of that object. And you do that iteratively, so you take further and further steps as you get out into the scene to figure out when you've hit something. So as you can see here, I haven't actually hit anything because I haven't reached my minimum distance that to get to the object. I haven't realized that, hey, I'm actually at a surface. But if you extend that further, you start to see it expand. And you can see where you're starting to actually hit things. And you return that back to your code, and you say, I'm going to display pixel of this color at this coordinate. So in a nutshell, that is ray marching, and that's used through through the rest of these examples. I created a basic bootstrap ray marching shader, which will be in the resources at the end of the slideshow. But essentially, all it is a basic algorithm to do ray marching, and the magic here all happens. If you forget the normal calc lighting, happens sort of here. And for this example, the distance for a sphere, if you want to calculate the signed distance field for the sphere, is calculated with this, right? Now, the benefit is you don't have to worry about having to work all this out. Some very smart people have already worked out the signed distance fields for almost every shape you can think of. You then take those and combine them. And you combine them using Boolean operators, so you can union them, you can subtract them, you can multiply them or add them. And that's effectively how you would create a scene. And for example, I created this for DDD Perth, where it's just some lights going around, but there is no geometry in the scene, right? This is all just, I'm picking a pixel in a screen based on its distance for something. And I can even show you what that might look like. If you take the O here, for example, and this is when demo gods strike me down. So if I was to just return, say, the main O, right? So I'm returning the distance to the main O. Oops. Alt, yeah, there we go. And I just get a sphere, because that's all I started off with. But then what if I returned the minimum? No, actually, I don't think I'd do the maximum will work. If I did the maximum value of the main O and say the whole, right? No, oh, oh, wrong one, my bad. Hold on, let demo god strike me down. There we go. So what I've done here is I've effectively negated the main O. So the main O is no longer visible and only the D's within it are, right? But you can create a mask. Actually, if I do mask, it might, no, oops. Ah. This is why you don't do live coding, people. So by doing this, what I've done is I've created an intersection between the O and the mask that I've got for the circle in the middle. And that's how you would create a scene based out of these primitives that you would create with sign distance fields. And when you start to look at that, you start to really appreciate what some of these more complex images really take to create. It's a far more so I appreciate that experience a whole lot more. Of course, the benefit is you can do stuff like this as well. If you were to try and create this sort of thing with traditional sort of 3D geometry, your machine would be on fire. But you can do this because you can do this in shaders because you're not affecting geometry. You are effectively changing the shape of the environment. You are affecting the environment, not the geometry itself. So this whole field of spheres is created just by applying a modulo to the sphere, and it creates all of these spheres. The intersections or the operators that I mentioned earlier, and because you're using sign distance fields, allow you to do cool stuff like if this thing is close to this thing, take this point and this point, and if it's close enough together, do something with it. And that's how you sort of get this glob effect. I'm really keen to try and make this into sort of a meta balls type of thing, or like a lava lamp. I think that'd be pretty cool. But you don't have to just do sort of shapes and stuff. Again, another mathematical ingenuity, or another mathematical principle, the Mandelbrot set. And it's a depiction of it, just zooming in, and it's constantly evolving. And shaders are really good at doing this because you get to leverage the GPU to process and crunch some of these things, which is really effective. And you get to do some cool stuff with distances from various places. So all of those are available on Shader Toy to take a look at. Right. Nope. Nope. So did it work? Did it work? No. It is changing here. Like it's changed. It's kind of semi-changing there, but I don't know. I don't know, man. This is. See, it just goes to show you, no matter how much you prepare, I tell you what, just do that and go back. Oh, maybe I've just got to do that. No, it's just not moving at all. Like I'm moving slides here, but it's not moving. Nope. Oh, there we go. That'll do. Yay, there you go. So, sorry about that. Shader toy requires a shift in mindset. And I think that's the key takeaway for Shader toy in particular. It's definitely not as approachable as something like P5.js. It is mathematically intensive. You do have to think about how you want to solve problems. And that can be a bit daunting, but it can also be very rewarding. I personally prefer creating stuff in Shader toy and creating shaders. They just sort of tickle my fancy, I suppose. But it also offers great opportunities. So things like fractals, for example, and that sphere field, you just can't realistically do that in something like P5.js. And I like the challenge, right? But at the end of the day, it's different strokes for different folks. There is no best tool. So use whatever suits you. Use whichever is going to fulfill your needs. And think about what you want to create. What is the best tool going to be for that? And more importantly, I think try to master one. I've tried to sort of do both, and that's been a challenge. I don't think I've got very good at either of them. I'm still learning. So try to master one. I think some of that stuff that I've shown you today, some of the other examples, those are from people who have focused on mastering one of them. So the key takeaways for today, you don't have to be an artist to create art. And I think it was Ralph Waldo Emerson who said every artist was first an amateur. So try it. Don't be scared to. Pick the tool that suits you and experiment. There is no right way to do it. And the creative part of this, I think, is the most important, less so than the coding. It's feeling free to try and do new things. And I just want to call out that all of this and everything I've learned, I've been standing on the shoulders of giants, and in particular these individuals, and especially the likes of Dan Schiffman, who's authored a book called Nature of Code, which is absolutely worth a read, and Inyo Quiles, who's just a master at Shader toy. Thank you very much.
Alrighty, guys. Thank you so much, first of all, Brandon. We've had a few technical difficulties. I will get that turned off, but thank you all for coming. Just a reminder, we do have morning tea in the foyer, so if everyone can make a move there, that would be fantastic.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Huh. Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hensman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Henselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink Beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Thank you for coming to our talk today. So today we've actually got a fellow Telstra Purple senior consultant with us, Brenton 80. He will be doing a talk on training a PowerPoint AI to play tic-tac-toe. Now, he is actually a tutor also for the University of Western Australia Data and Analytics Bootcamp. He's got a pretty interesting background with a Bachelor of Science majoring in Maths and Psychological Science, and a Master of Applied Artificial Intelligence on the way. Data is a rapidly growing domain, and it is his vision to spread awareness of the power that comes with taking control of data. Over to you, Brenton.
Wonderful. Cool. So, pretty provocative title there, a little bit clickbaity. Surely this is just a trick, you might say, just like a play on words to get you through those doors. And don't worry, we will get into it. We will get into this magical PowerPoint AI. But before we talk about that, we need to understand what AI is, what artificial intelligence is. More specifically, we're going to talk about one avenue that we get through to get to AI, which is machine learning. So, before we go any further, I feel like I do have to warn you guys. This isn't actually a talk about PowerPoint or tic-tac-toe. If you came in here hoping to get the latest tips and tricks on creating flashy slide decks and mastering the game of tic-tac-toe, then, well, one, I'm profoundly sorry, and two, you maybe should have read the talk description a little bit more. There's time to leave if you want. But AI then. AI is a term that floats around a lot these days. It's usually as some ex machina style magic to solve all of the world's problems, which, I mean, it's great for me because it means that I get to wander around pretending like I'm some Chris Angel in my day job analyzing data. But you see, a magician never reveals his secrets. The difference here, me, a data scientist, I'm going to take you behind the curtain and see how simple machine learning and AI really are, and how applicable it is to so many different scenarios, more than you might expect, even, say, a PowerPoint. But if we're going to talk about machine learning, and some of you might be aware of this, then there's something we can't avoid talking about. Maths. That's right. I tricked you all into a 45-minute lecture on grueling, repetitive, complex maths. Who's excited? Except, we don't really need to talk about maths to talk about machine learning. As much as I would love to get into intricacies of stochastic gradient descent or cross-entropy loss between distributions, those of you who just felt the blood rush from your face as I mentioned the word maths can relax just a little bit. But then that begs the question, if we're not going to talk about maths, what are we going to talk about? You see, if you looked on the definition of machine learning from our friendly site Wikipedia, you would get machine learning algorithms build a model based on sample data, known as training data, in order to make predictions, decisions, without being explicitly programmed to do so. That bit's important, so keep it in the back of your mind. But this is wild, right? This must be some wild new innovation. We've got sample data, we're making predictions and decisions. Except this quote is often attributed to someone called Arthur Samuel in 1952. Arthur Samuel was a pioneer of machine learning in IBM, and he was building systems to play checkers right back in 1949. But what about all this stuff I'm hearing about neural networks, computer vision? Surely being able to get a computer to see images, that must be new and wild, right? This is a schematic for the Mark I perceptron. This is an initial machine learning algorithm that was trying to mimic the workings of the human mind, which sounds super fancy. It was used in early computer vision models for image recognition in 1957. Now, although the technology has changed a little bit, the same fundamental principles are still being used today, and it's solely responsible for the resurgence we saw in neural networks in 1990s. This might be a bit strange, not what you would expect. But you see, despite what the buzzwords might say, machine learning is not just for big data. Machine learning is not just for large-scale compute, for people who have all the money in the world to throw at, which maybe Microsoft will get mad at me for saying. Machine learning it's not magic. If that's what machine learning is not, then what is machine learning? We're going to talk about what machine learning is, and hopefully by the end of this, you'll be able to come with me on the journey to how we can create machine learning out of something stupid. Machine learning is a way of constructing a model that describes things about the real world without having to explicitly program it every detail. In a way, it's about transferring knowledge from the known to the unknown. And we do this sort of learning in our real-day lives every day, so much so that it's pretty much second nature. When I was a kid, I spent a lot of hours playing the guitar. I probably should have spent more hours doing my hair. This is the sacrifices we make, right? Except for one time in high school where we were auditioning for a musical, which the mic is important. And maybe 5, 6, upwards of that amount of people were trying to audition for guitar, but no one was auditioning for bass. And I said, how hard can it be going from 6 strings to 4? Easy. Except any musician who has tried to transfer from guitar to bass will know that there are transferable skills. There's a lot more knowledge that you need to gain before you can successfully play the bass. My first few performances, I absolutely bombed. I started out thinking that I would have all my knowledge in guitar that would easily transfer it into bass, but this wasn't the case. It was only after successive practicings, learnings, failings, that I managed to get to where I am today. Put it another way, let's assume we have a group of people, much like yourselves, tasked with predicting the result of a coin flip. And for every correct guess, you get a cookie. That's just so that we make sure that people take this very serious experiment seriously. Without prior knowledge, except for the fact that maybe a coin has 2 sides, I think we can agree within a certain margin of error that 50% of the group will get a cookie. So we run this. 1 flip, turns up heads. 2 flips, turns up heads. 3 flips, heads, and what a coincidence, some might say. Others might start to catch on. 4 flips, turns up heads. 5 flips, turns up heads. And a group might start getting suspicious. Cookies are flying left and right. Given enough time, people will learn the ploy of this con man. 'Tis no ordinary coin. The group starts around here, 50%. But then with successive coin flips and the promise of cookies getting ever more enticing, we start to learn of the coin's true nature. By guessing and getting it wrong, or guessing and getting it right and being rewarded constantly, over and over again, we can start to induce that the information is not that the coin is a regular coin, but it is a double-headed coin. So, what is that? How can we abstract that away from that experience of us learning after successive coin flips and apply it to something in the maths world or the computer world? There are many types of machine learning that you might have heard of. Supervised, unsupervised, reinforcement learning, semi-supervised. But fundamentally, they all follow the same 3 basic steps. We need to create a test. What is the model trying to do? We need to define a way to score the test. How do we tell if a model is good or bad at what it's trying to do? And lastly, most importantly, we need to find a way to punish or reward the model for the score it received. So again, the idea here is that if we take the fundamental components of what a machine learning algorithm is, stripping away all the maths, complexity, and high compute power, we can find ways to implement it in something simple. And we need to know these steps if we're going to build an AI from the ground up with machine learning in, say, a PowerPoint, maybe. I don't know. Is that why you're here? Indulge me for a minute while we walk down Metaphor Lane. We're going to open up Brenton's School of Machine Learning Studies. In this school, we have students day in, day out trying to produce results. Our school is the model, and our students are just instances of training that model. To get this school to learn and perform in one of the top schools, we need to define a test. This test is how we're going to judge how well a school performs. When we conduct a test, each student will get a score, and our school's score is some aggregation of the student's score. Who doesn't love standardized tests, right? After the test, we need to define what it means to pass or fail it. What does it mean for a student to do well in the test? What is a good score? What is a bad score for the school? What will end up in us losing funding and turning off the lights forever? Lastly, we need to define how we're going to punish the students who have failed and reward those who did well. This is a standardized test, and again, our school will be based off the aggregated score of all of our students, so we want to maximize the amount of students passing by whatever means necessary. And we do this many, many times. Each time, a student is getting punished if it gets the test wrong, or it's getting rewarded if it's doing it better. it's important to note here that the students are the one learning after each test. They are what makes this machine learning school a machine learning model. And you can't just go ahead and reward or punish a school as a whole. Anyone who's tried to organize any group of kids will know that that's just not possible. What you do have control over is the individual students running their tests, and you have the ability to learn, to get them to learn or change their scores. Now you might say a different approach to this is to try and get every student to memorize the answer of every single question in the test. Which, yes, it's an option, it will get a pretty good score, but then say a new school board runs around and says, we don't like this test, we're going to define a new one. All of a sudden, you have to do all of the rework in getting all of these hundreds, thousands of students in the school to relearn their answers. It's not efficient, and I know that I can't memorize a standardized test for the best of days. The key thing here is that you can run a test on any model, but if there exists no process to punish or reward the model based on the test score, then it's simply not a machine learning model. So that's a little bit of fun down metaphor lane, but let's look at this in the real world. What you're looking at here is an example of the MNIST dataset. It's sort of said as the hello world of computer vision, whatever that's worth. It's a dataset containing 70,000 labeled, handwritten digits. 60,000 of those are training and 10,000 of those are testing. The name of the game is to get a model that classifies an unseen handwritten digit as 0 through to 9. So in this case, our test is pretty simple. Is the predicted digit equal to the actual labeled digit? So, if we try and approach this in the simplest way possible, our first model might be a random guess. This is about as simple as we can get. We just simply randomly guess a number between 0 and 9 and assign the label to be that. This model is quite easy to test, actually. In fact, if we did it, then we would find that it's about 10% accurate. And that's much like guessing a random coin is 50% accurate. However, we have no way to change the model's behavior when it gets things right, or we can't alter it when it gets things wrong. Our model's accuracy will always be 10%. Hence, our model is not a machine learning model. So, 10%, not that great. 1 in every 10 digits gets it wrong. So let's try a better approach. This time, we're going to relate a model to the image's darkness, which might seem a bit strange, but you might expect an image of an 8 to be darker than an image of a 1, and maybe a little bit darker of an image of a 3. There's more ink involved, so there's more darkness. This model is a little bit better. In practice, we see that the accuracy averages to about 22%, which is twice as good as randomly guessing. But it's still only 1 in 4, 1 in 5 getting it right. I think we can do better than that. Crucially, again, there was no way to alter the model's behavior. When it's dark and it predicts it to be an 8, it will always do that, regardless if it was just a really heavily highlighted 5. So let's see if we can apply what we just learned in the school metaphor for creating machine learning algorithms. Don't worry about the code in too details. This is an extract taken from a book that I dearly love called Neural Networks in Deep Learning by Michael Nielsen. For those interested, this is again what we call a neural network. But crucially, what this has is what the other two models didn't. It has a way to reward good test scores and punish bad ones. Every time it runs its own test, it will find a way to calculate how different the predicted value was from the expected value, and then alter the model in some way that favors the way that it got it right. The key magic in here is we have feed-forward back propagation approach. This takes the output of a cost function, cross entropy in this case, to test how different the prediction was from the expected, and it alters the model based on stochastic gradient descent, which honestly, it's pretty simple. It's just based on the train rule of deriving matrices, except I said no maths. I'll breathe. model here is a machine learning model. It had a test. Is the predicted value equal to the actual labeled digit? It has a way of determining a good or bad score. In this case, I said it was the cross-entropy function. And it has a way of altering the model's behavior, the stochastic gradient descent. You don't have to know how it works, you just have to know that it's there, and there's a method of applying this punishment or reward. But the MNIST is a pretty typical example. I said it was like the hello world of computer vision. In it, we had a very clear, labeled objective. If our model didn't predict the correct label for the digit, then it's not up to scratch. Sometimes the test and the score aren't so clear-cut. The interesting examples in the industry are when the test isn't so clear and a bad score is equally just as vague. See, labeling digits is easy. But what about if you're trying to transcribe somebody's piano playing as an audio file and transcribe that into manuscript, music that somebody would read? This is a paper called Onsets and Frames, Dual Objective Piano Transcription, and they tried to do just that. Now, the paper is full of fun maths and data science jargon, but the point of interest here is when the authors tried to describe how they based the model accuracy for velocity. As they say, it's been a pretty hard nut to crack. I mean, sure, you can tell if a note written on paper is the same as the note that was played. You can even test whether the transcribed note falls on the same beat, give or take. But how do you capture dynamics, volume, expression? A note pitch is a note pitch, but what reference does a note's loudness have? Who's to say the recording just isn't really loud or there's a lot of background noise? Additionally, how do you correct a given note's volume based on when the context that it appears in is arguably more important? A soft note compared to a really loud note has different meanings than if you would just have a sequence of soft notes. So, I love academic papers. The authors are kind of hand-wavy at this point. They're saying that they've discovered a never-before-seen method to truly test whether their model perfectly transcribes the dynamics of a player. Forte, fortissimo, piano. However, it's important to note that all that's been done is some math magic to calculate a score based on the average volume of the recording. They didn't discover any brand new method. They simply defined a test. The test could have easily been all notes of the correct volume if they're below -5 decibels. That's a test, and the model would have been really good at transcribing all notes that are below -5 decibels. So these are the 3 key things that we got to keep in our minds moving forward. To have a machine learning model, you have to have a test, a score, and then a way to punish or reward based on that score. Sometimes these are pretty easy to understand. Say, for example, if is your digit equal to the labeled digit? Sometimes it can be a bit more vague in the case of when you're trying to transcribe music notes or when you're trying to play tic-tac-toe, for example. So that was a lot. But this creates the fundamentals of what we're going to use as we go through the journey on how you might do something strange. See, machine learning is more than just classification and regression. Machine learning can be used in any application that uses the 3 key principles when you define a test, when you calculate a score, and then provide some sort of punishment or reward. And if you don't believe me, well, this is where the fun comes in. Training an AI to play tic-tac-toe. Except that might not really get you convinced, right? Maybe I'm just going to pull out my Python and do some math magic, and then that doesn't convince you at all. What about if we tried to find a scenario in which we didn't have any of that available to us? We don't have any code, we don't have any fancy compute. Yeah, I think this will do a better job. I mentioned before Arthur Samuel, who spent a large part of his career utilizing the best IBM computers at the time to create revolutionary new machine learning programs. I wonder what he'd think if he saw his whole life's work reduced to a slide deck. Now, in true typical consultant fashion, I will label some caveats here and really define the scope of what we're going to be working with. The aim of the game is to demonstrate that machine learning is no more complicated than any other algorithm once stripped down to its fundamentals. Hence, no code is allowed. Now, full disclosure, I did use some macros. As you will soon see, to get this working involved many slides and many animations. So to save myself an eternity, I hacked some old VBA scripts to automate the insertion of animations and slides. We will not be using these in the method for training the PowerPoint. I want to make that very clear. Secondly, for the game theorists out there, there is about 255,168 possible games of tic-tac-toe. This number varies slightly depending on how you define what a game of tic-tac-toe is, but needless to say, that's a very big number. So to narrow this down, I've reduced the problem to training a PowerPoint tic-tac-toe to win in 3 moves. Or more likely, it's training a tic-tac-toe to not lose in 3 moves. But that's not as catchy. In addition, the AI will always make the first move, and always in a corner. See, the game of tic-tac-toe actually varies quite significantly depending on which player goes first, so we're going to just highlight one example of this game state. Where possible, we'll utilize reflections and rotations, so that a computer will never make a move that is a reflection or rotation of another state that it can move to. What does that mean? In this example, there are only 3 places that an AI will try to place itself. The left, the bottom left, and then the bottom. This is because the other blank spaces are just reflections of those moves. The right and bottom right are just reflections of the left and bottom left. Us human players will have no such restrictions. This leaves us with a still not tiny number of 1,830 possible game states that you can have for tic-tac-toe. I'll take the time here to thank the inspiration that cursed me with this project. First was the work by a mathematician and comedian, there are some of us who are funny, by the name of Matt Parker, who ran a project on training a machine learning algorithm to play tic-tac-toe based on a set of matchboxes. And this was off the work of Donald Mickey in 1961. If you ask me, they're kind of cheating a little bit. They only have to deal with this approximately 700 possible states that the tic-tac-toe board can be in, and there was a lot of human intervention. So, not throwing any shade. But the second was a video by Tom Wilderheim, who really opened my eyes to the programming potential of PowerPoint in his Absurd Ideas in Computer Science PowerPoint Programming. It's a great watch. So PowerPoint then. Now, I've heard from the streets that some people are under the false impression that PowerPoint is not the greatest tool ever invented. You laugh? I'm shocked. I mean, PowerPoint has literally everything you could want from a programming language. It has text. It has shapes. And most importantly, it has animations. That's a totally random animation, by the way. It's the first time I'm seeing it. It's always fun. You may laugh, but the shapes and animations are actually the key to what allows us to form a real machine learning model with PowerPoint, because they allow us to do something that developers take for granted every day: state management. In our model, each slide will represent a particular move from either the player or the AI. We will then use these shapes and animations to manage that state, to remember what they learn. So, our model will consist of 1,830 states, which is 1,830 slides. Each slide state consists of the following. Simply, the board, which is the number of noughts and crosses in their relative positions to each other. In this case, AI is cross and human player is naught. That just felt right, I don't know. And also, we contain all of the previous steps that got us to that state using one of my favorite PowerPoint features, zoom transitions. So this encodes all of the information that got us to the state that we were in. It allows us to back propagate through each path and get to the slide that led up to it. So that's the state. That's what we're trying to capture in a slide. But how do you transition from one state to another? Well, there are two different types of turns. There's a player's turn and an AI's turn. For the player, a collection of shapes that place a naught and navigate to the relevant slide are on every single blank space. They're invisible, so they don't have any fill color or outline color, but they do have a hyperlink to the slide that is relevant. Every click on an empty space navigates the user to a new slide where that naught is in the location that was clicked. So for this slide, there are 8 invisible shapes, but they are there, and they hyperlink to the relevant slide. When a user clicks one, we go to that slide. And notice in the top left-hand corner, we've saved the state of what it was previously by using the zoom transition. So that's the player, but what about the AI? How do we get the AI to navigate? And this is where things get interesting. Now, to be sure, a human player still clicks the AI. We're not building a PowerPoint to control a mouse just yet, although don't give me any ideas. For the AI, there is also a collection of invisible shapes, but these ones blink at semi-random intervals. The difference between this navigation and the previous navigation is that all the shapes are in the same place, except only one is visible at a given time. When a user clicks on the button labeled "Click to make AI move," I'm no UX designer, but that's pretty self-explanatory. It instigates the animations of each shape below it clicking. So this is for demonstration. In reality, those shapes are invisible and they're blinking a lot faster, and there's a lot more of them. So that's it. Our model consists of 1,830 game states. 301 of those each have an AI making a random choice to proceed to the next move. Now, I say random choice. Currently, we're set at a ground state for the model. And think of ground state as just predicting 50-50 on a coin toss. What we want to do is to change from that ground state into a state that is optimized for playing tic-tac-toe. How are we going to do that? Let's call back to what we learned just a few minutes ago. We're going to use machine learning, so we need to define a test, a score, and a way to punish or reward the AI for making bad or good moves. So, if we do this, we can verify that what we've indeed created is a machine learning model, an AI, for in a PowerPoint to play tic-tac-toe. First, our test. Due to the limited time of a lone man's calendar and the absurd amount of games of tic-tac-toe, I said that this test is, does the AI win in 3 moves? The converse is true. Does the AI lose in 3 moves? Next, our score. Now, the number of winning games is not evenly distributed among the total number of games of tic-tac-toe. What I mean by that is there are far more games where neither the player nor the AI win. So for this score, we're going to consider 3 results. Pass, the AI wins. Neutral, neither the player nor the AI wins. And 3, the AI loses. Passing represents the best possible score that we could get, and we want to encourage this as much as possible because it happens so few times. The failing is a bit more common, but we want to discourage this from happening, and neutral is pretty much the most common. So, this translates to how we're going to punish or reward. When an AI passes and it wins in the first 3 moves, we want to give it an extra chance so that it will navigate to each slide that leads to a winning move. That's signified by a +3 chance. Neutral, nothing happens. We don't want our AI to just lose all of its chances to navigate. Fail is we take away the chance to navigate to the particular slide that made it end up in a losing position. So, how are we actually going to do this? This is the fun bit. This is the reason why we had to have that absurd arrangement of shapes blinking and all of them on the slide. It's also why we have to save the previous state that we were in throughout the whole path of the game. So I said that each move in the AI state has a absurd amount of blinking shapes. Now these shapes represent the probability of moving from one state to another. In the ground state, I've initialized it with 10 shapes each to move to each available location that an AI can move into. In this slide, there are 7 places that the AI can move to. They're the blank spaces, because there's no symmetry here. And because there's initialized with 10 shapes each to navigate to those slides, there are 70 randomly blinking shapes on this slide, each one representing a chance to navigate to the state that we're going to move to. So, when an AI runs a test, if the results were good, that is, the AI wins in the first 3 moves, then we'll track the moves it took to get to that state. This represents the best possible play that an AI can make. Somewhere along the line, the player has made a mistake, and the AI has a chance to win, and it does. We want to reward this as much as possible. What I mean by that is we want to reward every state that came before it to appear again. So, we add more of those shapes that are randomly blinking that hyperlink to those slides. And we backpropagate through every state with that. So it starts with no pieces on the board. When we click the AI moves, we want to encourage it then to move to the next state in which it will win. However, let's say the AI makes a bad play. Somewhere along the line, it might have even had a chance to win, but then it doesn't. It makes some sort of fatal error and leaves it open for the player to come in and attack. We want to discourage this from happening. If it's in a position where it can either win or draw, we don't want it then navigating to a slide which represents a state that a player can then win. So, every time we run a test and it loses, we backpropagate through every slide that we have and take away one of those shapes that navigates to the slide that ends up losing. And that's for every single slide along the path. This way, when it's at a fork in the road, when it doesn't know where to put it, there is more chance that it will move to a slide that wins or is neutral, but there is less chance that it's going to navigate to a slide that loses. If the test is neutral, that is, neither the player nor the AI win, we simply just do nothing. So, this is an AI that's initialized with random choices, but you'll be able to see as we go forward how it works. The player is just put in the center, and we click again to make the AI move. In this case, the randomly blinking shapes promoted us to navigate to a slide there. Now, a player made a mistake there. The AI has a chance to win here. An optimized model would put it on the top. But because there's an equal chance currently for the AI to navigate to the wrong slide, it doesn't. It makes a mistake. We're going to discourage this from happening by navigating back through every slide and taking away one of those randomly blinking shapes so that if it's ever in the same position again, it has less chance to navigate to that losing slide. And then we do it again. The AI will make a move in the top left-hand corner and the player will make another move. This time the AI made a different move. It's setting itself up right to win, but a player blocks it. The player now has a chance to win, so an optimized AI with all of the navigation shapes configured correctly will try and put it in the bottom. But again, it makes a mistake. So, moving forward, we discourage that by taking away every shape that leads to this state from the PowerPoint deck. And this is a long, grueling process. There is a question that I'm sure a lot of you have been asking throughout all of this. How many games? To be sure, I mean, it's great to say what machine learning is not, maybe break the stigma of how it can be used, but why does the fundamentals of the understanding machine learning matter, besides the fun of knowledge for knowledge's sake? Why did I go through this whole process of constructing a way to train a PowerPoint to go through a machine learning algorithm? What I hope is clear by now is the distinction between traditional control logic and the machine learning approach, And that's all it is, an approach. The difference suggests a fundamental change in how we conduct analysis, build automation, and program. In the other models we saw, predicting a digit based on its darkness, or randomly guessing, are examples of this traditional logic. If this, then that. However, machine learning, if nothing else, is a tool that allows us to move past this constrained test. It's not possible to know every then this, and it's certainly too time-consuming to label every then that. Machine learning allows us to tackle problems that we couldn't possibly know how to tackle. Machine learning is not just predicting digits or analyzing text sentiment, but any process in which we can test, score, and provide feedback. All of the advancements in machine learning, the maths, the distributed compute, are just ways that we can extend this process of creating fancy tests, scoring it, and then running it again. In cases, like I said, the cross-entropy loss, which sounds pretty fancy, but all it is a way of getting our list of numbers that we predicted and the list of numbers that we expected and doing calculating a score that is kind of easy to comprehend. Sometimes it's not as easy, so the researchers have to go above and beyond to try and think about what they're even trying to test. An example like the audio transcription paper that we saw, where they were faced with a problem that isn't immediately obvious what we do, so they, rather than diving into let's just pump it with more compute power, it was let's take a step back and what is it that we're even trying to test? It's are the dynamics correct? In a PowerPoint example, it's not how can we somehow make some code in PowerPoint, although PowerPoint is Turing complete. It's a way of analyzing what we have to work with, shapes, slides, and animations, and how can we use those to do the fundamental components of testing, scoring, and providing feedback by adding and subtracting shapes. The animation allows us to navigate through states, but it's simply taking away and adding shapes that allows us to provide feedback. In the end, machine learning taps into something that we take for granted, but applies it in a programmatic way. It's our ability to learn before knowing. So thank you. On the slides here, I have some of the resources that I did mention. Neural networks and deep learning is the book all around the fundamentals of neural networks. I started using the terms AI and machine learning a little bit interchangeably, but as I mentioned way at the beginning, machine learning is just one avenue that allows us to get through AI. And it's one of the most popular, and it's certainly useful. Neural networks is another subset of machine learning. It's a particular interest of mine, but if anyone's interested in learning more, I recommend that book. Onset and Frames, Dual Objective Piano Transcription is the paper that I maybe flippantly was reviewing. I want to be clear that the Google Lab team and everyone that worked on that, incredible work, but it does provide a good example of how in the real world sometimes how we test and how we score isn't immediately obvious. Menace, the pile of matchboxes which can learn. If you want to look at this, but done in matchboxes, have a go at that. But I mean, they cheated, right? They had a whole bunch of people working. This was just me and a PowerPoint, which is a lot sadder than now I'm saying it out loud. And lastly, Grading Practical Ideas in Computer Science, PowerPoint Programming is a hoot. It's a long one, but if you want to see a Turing machine in PowerPoint, there's your go. If you're interested in a follow-up, you can at me on Twitter, LinkedIn. You can go to the blog site that I occasionally write. I do have a working version of this PowerPoint AI, as you saw in the video. It's not yet optimized for playing tic-tac-toe perfectly because it takes many, many iterations of running the test, adding and subtracting the shapes, and my friends didn't find that interesting on a Saturday night. So yeah, please reach out to me if you're interested in versing a PowerPoint in tic-tac-toe. I lastly want to thank all of the sponsors for DDD. They're the people who allow us, me, to stand up here and talk about something that I have no right to be talking about, a PowerPoint AI. And also thank you to all the volunteers who woke up very early today to get this all working. Thank you. think we have time for some questions.
Perfectly on time, so we've got 5 minutes for questions if you want to.
Yeah. I think we got a question there, yeah.
Oh, thanks. So you said machine learning is one of the ways to do AI. What are the ways?
Yeah, AI is like about as broad as term as you can get. Some people consider things like statistical models and everything to be part of AI. So that's not something that uses an iterative approach. But you know, things like probability tests and t-tests. Other people, natural language processing is a really interesting example of AI that isn't machine learning, because there's a whole bunch of still maths, still linear algebra and stuff, but they don't do the iterative approach. They just do like vector multiplication and stuff like that. That's simplifying it a lot, but there are, yeah, those are some of the examples.
Next question, guys.
I was pretty impressed with what we've seen today, but I just wanted to ask, what's next?
What's next? Oh, well, I mean, Go is one of the most complicated games you can play, maybe. No, I don't know. I mean, to be honest, this is just a fun example. Maybe I've spent too much time on it, but it was more of an exploration into how fundamental machine learning actually is. I'm not sure I'd do something like this again. Yeah, unless you sat me down in a torture room. But I can't stress enough how many hours it was to form that board. But yeah, I'm always keen in investigating these sort of weird approaches. So, anyone else?
Lucky last question, guys. Anybody?
Wonderful. Oh,
we've got another one
Please.
here.
I'll talk about this for hours.
Oh yeah. Yeah, I'll ask another question. So I was just curious with the PowerPoint. So I never thought of it, but so there's no code. You just literally have a PowerPoint that just click through it.
Yeah.
So someone was manually doing the like punishments and rewards.
Yep.
Wow. Okay.
Yeah. Like I said, there was macros involved to like insert the slides. I'm not gonna copy and paste 1,830 slides. But yeah, those macros weren't used for the actual training of it, because that kind of defeats the purpose. This would be easy to do it in VBA or something like that, but it'd defeat the purpose of the whole exercise, I think. Personally, I mean, maybe I'm just sadistic, but yeah.
Look, thank you so much, Brenton, on behalf of all of us. That was a fantastic speech. And if I can, guys, a big round of applause.
Thank you very much. That's it.
All right, guys, in here in about 10 minutes, we're going to have George Coldham and Swen Lee.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
This is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster. You know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
We got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates.
If I can get you to just quieten down for me, I will close that back door just in a moment. So, right now we have two wonderful individuals. To my left, I have Swen. It is Swen's first time presenting, so please give her a warm welcome. Now, Swen is a final year student studying a Bachelor of Computer Science with a major in cybersecurity. She's also a student ambassador for the School of Science at ECU and is also doing an internship at Retrospect Labs. Damn girl, you're busy. George, you're a tech geek, 20 years. By the looks of things, you're also a gamer at night.
Yes.
Love it. On that note, I'm going to hand it over so I don't talk too much. Good luck.
Thank you.
Thank you.
All right. Everyone can hear me fine? Yeah. Cool. Man, I know so many of you in the room. It feels like a family reunion. This is awesome. So thank you for coming to the talk with me and Swen. Before we get started, I want to say thank you to all of our sponsors, because without the sponsors, we don't have this amazing day. I'm not sure if any of you have been involved with running conferences before, but without sponsors, they're near impossible. And like to get a conference like this for $60 is just like, it's unheard of. So it's really cool. So thank you very much to the sponsors.
So this is the agenda we will be going over today. What can go wrong, which may lead to financial loss, what we can do to reduce the risk, and a short wrap up with the key takeaways from today's talk. Sorry, forgot to introduce myself. My name is Swen Lee. Like she said, I am a final year cybersecurity student at Edith Cowan University. I am also a mini vlogger on Instagram during my free time, and I play a little bit of ping pong when I'm not rushing my assignments. And I can play a few instruments, like the piano, the electron, the guitar, but not all at once. So over to you, George.
Thank you. So for those that don't know me, I am a cloud solution architect at Microsoft in the cybersecurity. I do a lot of stuff with the Defenders. So if you've heard of the Defender products, then you know what I do. I play games. I play lots of Rocket League. I'm a champ 1, but I should be, a grand champ. And I'm also my dad. I've got 2 little kids, and they like to share, in case you've heard my sexy voice. I don't normally have such a deep voice, but yeah, so that's us. So I've got to fess up, it's a bit of a clickbait title with the talk, so thank you for voting us in. We do have like a serious topic to talk about, and we'll get into it right now. But so how can you lose your money, and what can go wrong? So I was trying to put the talk together. I've got Swen, who's our, my protege and wants to learn how to talk at conferences. So what's a nice topical, generic subject we can speak about in order to educate and, not be too deep and intimidating? I'm like, well, let's talk about SIM swapping. Has anyone heard of SIM swapping? Manual. All right, so just imagine you're holding your phone, scrolling through TikTok and sitting there waiting for the bus or whatever, and then all of a sudden your data stops, and then you look at the top and instead of it saying Optus or Telstra or Vodafone, it says SOS. That's the experience you'll receive when you've been SIM swapped. Essentially what a SIM swap is someone fraudulently pretends to be you and steals your phone number. All right? So why do they do that? Most banks are pretty sucky with their security, banks, and especially Bankwest being a sponsor. But like, you know, your MFA normally is SMS with a bank. So if you own the phone number, then they can pretty much say that they're you, verify money transfers. The other reason why SIM swaps can be somewhat effective is, especially on a prepaid service, you don't need a lot of information to do a SIM swap. So I thought I'd do a SIM swap on myself. I did it with a prepaid that I registered, and then I got another prepaid SIM. I'm not going to do it with my details, but basically you can see here, this is the number, and I needed to know these two things, right? So these can be found reasonably easy. Like, if a hacker was doing this, you'd assume that they've already compromised you in some way, probably have got your email box. There's like a statistic, like 98.9% of Gmails do not have two-factor authentication turned on them, right? And odds are a lot of people are quite sucky with their passwords and reuse passwords. And we'll talk about that in a little while. But so to do a SIM swap, you need to know a phone number and you need to know the provider. And then all you need to do is have an ID type. So for circles.life, you need to have either a driver's license, a Medicare card, or a passport number. But they don't actually verify that. You just need to know the number, right? So there's my license number. But you know, because it's so easy, I'm not going to give it to you. There's my first name, my middle name shown on my license, my last name. Then you need the date of birth. But if you've got the license number, you've probably got the date of birth, right? Like an attacker's going to be prepared. They're not going to be like some schmuck like me trying to simulate it for your benefit. So, you know, and you need the email. But once you've got that, like to me, that's not a very high bar if you're able to compromise someone's email. And then you verify it with a code sent to the email. It's blurrier than I thought it would be, sorry. But then that initiates the SIM swap. So that was the text I got. That was the validation of the ID. But you saw that was all of the information I gave them. So you don't need the physical ID, you just need the information. And I know that like in the past when I've traveled, say overseas, I've taken a scan of important documents just so I don't lose it. If in case, you know, I lose it, I can prove who I am. So I haven't deleted that. I don't know how long people have had the same mailbox, but I've had some for 15 years, and that's got a lot of PII in it, and if I lost access, then I'd lose it. So
you may ask why you should care about all this, and what does all of this have to do with you as a consumer? Well, as consumers, we need to protect ourselves against hackers. Well, that was meant to be humorous, but never mind. So next up, we are going to talk about potential attack vectors which may lead to account compromise. There are many websites that have been compromised. TryHunt publishes a site you can use to see which one of your accounts have been compromised, if they are. So this is a very popular website called Have I Been Pawned? We actually use this at Edith Cowan University for our cybersecurity workshops as well. And just simply key in your email address or your phone number, and this website tells you whether or not it has been compromised and how many instances that has happened. So this website keeps a database of accounts with their credentials compromised. As we can see here, there are 626 websites hacked, 11 billion accounts breached, and I don't know what those two are, but yeah. Password reuse. So even if you secure the data well, the user might just give it away with poor password hygiene. So can we have a show of hands of how many people here reuse the same password across multiple sites? Wait, I want to know who those are. I want to hack you. Oh, wait, sorry about that. So, anyway, according to this website, dataprod.net, on average, the same password is used to access 5 different accounts, which, like I said, I wanted to hack you guys. So if you could just write down your credentials and put it over here, I would very much appreciate that. I'm sure this has been enforced in a lot of account logins, especially in organizations. Multi-factor authentication, or MFA. When you develop an application, encourage or enforce your users to register for multi-factor authentication. Ideally, you do not build your own authentication process, but leverage an authentication provider that manages the user accounts securely and provides a secure authentication process with 2-factor authentication. Hyperscalers all allow for it. For example, Azure and other dedicated providers for authentication like Auth0, who has their booth right outside, or Microsoft Authenticator, and so on.
Just don't use SMS for MFA, because we've already proven that it's kind of a sucky method, right? So dependency hell. When you write software, you don't write everything from start. We just said don't roll your own authentication. Like that's a rule that people hopefully all follow. But at the same time, you know, if you've got to log files, you don't want to write your own logging solution. There's logging solutions out there. There's this awesome one called Log4j. People may have heard of it. Then there's, you know, maybe you want to upload files to a website or a web server, collect documents. You use a library or you use a dependency. But the problem is, when you use it, you don't know what's in that library. It can be like a real mess, right? So this is a comic. If you go find it, you'll see like there's this piece of string from this chaos all the way, you know, so it looks nice and harmless here. You trust it because it does what you need it to do, but it's a mess. All right, so who wrote it? What checks have they done? Is it safe and secure, or are they, you know, gonna give your data away? Oh look, Log4j. So if you don't know what Log4j was, it was like the most fun Christmas present security team was ever given. Because basically there was a vulnerability which anyone could exploit by using a URL from memory. And then they patched it and the patch didn't work. So they went through all of this trouble to patch it and it didn't work. So then they had to patch it again, but then that didn't work. So they had to patch it again and they fixed the problem by actually removing the feature. So it was good time, and like it's been used in so many places that it was a real nightmare. And the other example we've got for this is the Tiny File Manager, which I'd never heard of. I actually searched through CVE vulnerabilities looking for examples that were pretty straightforward. This package allows you to upload files in a website, right? And this one here, if you upload a file and that file has the right file name, you can actually put code in the file name and it would execute the code. So it seemed like a pretty simple one to execute if you knew that it was vulnerable. So, you know, you just want to be able to upload files. You don't care how it does it, but maybe you need to.
Okay, let's talk about storing customer data. Authentication. We need to ensure that the user is the person they say they are. By authentication, this means that only an application is allowed to access certain data. For example, when we have a server on the back end that manages multiple websites, and we only want website A to be allowed to authenticate database B. Access control. That means to check if a user is allowed to access an application or a database that he or she is trying to access. For instance, a human resource manager of a company is allowed to access a database that contains employees' information, but an IT admin does not. This will also prevent hackers from easily obtaining a company's sensitive information.
So this also applies if you're writing an application. You can have a service principal, which is like a user account for the application itself. You can assign only the permissions that it's needed so that it can only authenticate against the services it needs to authenticate. And then once it's authenticated, it can only access the data or services that it needs to access. So it works equally the same with a human or with an application. And then we've got two more parts around the storing. We're looking at the encrypting data when it's at rest and when it's at transit. So just assuming your service is compromised and they are able to steal that data, if it's encrypted at rest and you haven't done something silly like put your encryption key in your code, then odds are they're not going to be able to do much with that blob of data. Like a modern encryption system is such that it can't be easily cracked, even if you're leveraging the power of a nation state. And then also in transit, when you're sending data between network services, or a modern web service would have multiple components. Sending the data between those components, you want to make sure you're using an encrypted channel, because especially if you're using cheap providers or trying to rationalize across multiple providers, sending that data, it might go over the public internet or it might go over shared channels. So if you have your encryption, you're maintaining privacy between your different endpoints. So it's super important to make sure you're using encryption. So we've got some key takeaways. Passwords are terrible. If you can, move away from passwords. Probably a bit hard if you're just writing a web app to do your fantasy football or something. But you still could, not to shill Microsoft, but I work there, and Authenticator allows you to do passwordless, and I know that other authentication providers allow you to do password like through a push notification. So then your device becomes your password, and it doesn't have to be tied to your phone number, which is good. Second, software dependencies you rely on might be your undoing. So please be sure that your dependencies, or your software libraries that you're using, that they're safe, and you've got some sort of process to make sure that they stay updated. You can't write everything, you have to rely on it, but you also need to have a process to make sure that it stays safe. And lastly, make sure you store your data securely, because that's what your customers trust you to do. Thank you.
Alrighty guys, first of all, that was fantastic. We do have some time for questions, so if you want to pop your hands up, I'll come around with the microphone and you can feel really cool like me and talk into it and ask a question. Come on guys. Yeah, you are my man.
Thanks guys. So just a quick question on passwords. So what if you use OAuth that uses Google to log in? Is that better than passwords?
Oh yeah. Yeah, like a hyperscaler is going to do a much better job than yourself. Or, even if you're leveraging like a PHP library or something like that. Just think, if you can outsource to a company that is doing millions of logins a day or a second or whatever, then they're going to have a lot more better protection.
I'm going to chuck a question in. Should I go and put my email address in that? Have I been pawned?
Yes.
Seriously, I should probably do that between
all
the
of your
break.
email addresses, yeah.
Okay, cool. We learn something new every day.
I just wanted to ask, what is your opinion on authentication tokens, or the ones that do the generation numbers that some companies give you?
Oh, like an RSA token?
Yeah.
Yeah, generally pretty safe. I mean, because you need to have registered on the device that you trust, whether it's your little token or if it's the Authenticator app on your phone. So there's only one source of that 6-digit number to log in, right? So when you lose your phone, it's a pain in the, because you sometimes have a whole series of codes that you can use as one-time logins to prove you are who you are. But even if someone does a SIM swap, they're not stealing all the data on your phone. So if you've got the Google Authenticator, Microsoft Authenticator, LastPass Authenticator, Twilio Authenticator, there's authenticators everywhere. If you're using just one of those, then that is the source of truth. Even if someone steals your password, good, let them.
Doug, there was one
here. Just curious, you recommended we try to use different passwords for different platforms. I do know we have some free open password manager tools. Do you recommend people to use it? If so, what kind of tools do you use personally, except the keychain like iPhone use? So yeah.
Do you use one?
Personally, I do not, but I have my organization people sitting over there, and they use Bitwarden as their password manager. I hope they don't kill me when I get off the stage.
I don't want to read that report. I use LastPass and LastPass, but that one's a paid one. But I'm lucky because I became a customer in like 2012, so I only still pay $12 US a year for it. And the other one, which is on the Have I Been Owned pass, key pass? No. 1Password, thank you, yes. And I also use my phone, but it syncs across, yeah.
And Sven, I don't think you'll get in trouble. You can hack me later from what I've worked out. We might make it up.
We'll talk about this later.
Yeah, hi, thanks for that. I was going to ask about password managers as well. So some of them are offering the MFA functionality in there as well. Do you think that's a good idea, having the password and the MFA?
Yes.
Like 1Password, for example?
Yes.
And then you mentioned LastPass, but even the password managers are getting compromised.
Yes.
Like they had a recent issue in their dev environment, I think, and I don't know, what's your take on all that?
So LastPass was compromised only a week or two ago. Like their servers got done, and I'm completely comfortable with that because the way LastPass works is they just get an encrypted blob of data, and your master password is the key to decrypt that blob of data. So, you know, if they can guess the password, and that's not like a random generated one because I have to type it from memory, but it's still, you know, almost 20 characters long. So I feel good about that. I'd feel bad if there was like poorly written code, which meant they could bypass the encryption key or do it another way, then I'd feel really sucky about it. Having the MFA in the same solution as the password manager, I'm fine with, because my password manager, I can log in on like, I don't know how many devices, but the MFA still stays on that same device, and it's like that single source of truth still. So if, you know, you buy a new phone, you need to transfer that MFA from one to the other. So yeah, it's pretty good.
Thanks for that, guys. So that is time.
Yep.
Just one more quick round of applause. These guys have killed it. And Sven, I look forward to seeing you next year too. All right, guys, we do have another session in here. I have just lost my notes, so give me 2 secs and I'll let you know who it is.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster. You know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
A bit of an intro. So Josh is here with us today. He's a distinguished technologist at Contino. He's also a published author, which I think is bloody wicked. He's generally referred to at Contino as the break glass in case of emergency made human. He works with businesses all over Australia, helping them to digitally transform. He will also be taking some questions, and from what I hear, that signing of the book could be a possibility, guys. So Josh, are we good?
Hopefully.
Let's give it a red hot go. If you can, use that one so we can all hear you.
I mean, people can probably hear me. Oh, God. People can probably hear me anyway, so I'm generally loud. All right. Serverless testing, local considered harmful. So people may have heard me speak before, in which case you might have presumed this warning was coming. There's going to be a lot of strong opinions. They're hopefully loosely held. Your mileage may vary. I'm not saying I have all the answers, just most of them. So, we'll have to see how that goes, right? All right, the hero / villain for our story today is a friend of mine called Richard, who I worked with in the UK. He's drunk the cloud native Kool-Aid. As you can see, that is a suit he actually owns. So when I talk about cloud native, I'm not meaning this unholy Cambrian explosion of things that the CNCF has. Really, it's building for the cloud, not just on the cloud, right? That can mean Kubernetes, but I argue in most cases it probably not. But okay, so back to Richard, and we're gonna start, and I always try and start this way, so when people get bored of me speaking, hopefully they've got the takeaways to start. So we're gonna start with the 3 key takeaways. The first is that the testing pyramid that we've all held dear to our hearts for many, many years is a serverless anti-pattern in reality. Hopefully some of these are contentious. I'm hoping to, piss people off as we go. Again, it makes it more fun. Second, emulating the cloud is a recipe for disappointment. I will be ragging on local stack for about half this talk, maybe not half, but you go with me on this, and hopefully I can convince you to throw it in the bin tomorrow. And the last is testing doesn't stop when code hits production. Again, hopefully people agree with me on this, or they don't. Either way, hopefully you agree with me by the end. So there's already an intro on me, so I'll go very, very quick. So yeah, I'm a distinguished technologist at Contino, which is a ridiculous title. I work with enterprises. I've done world-first service architecture on AWS. I've done mainframes. I've done machine learning. I am a speaker, and I do have a few copies to give away. I can sign them if you want, but I feel really weird doing it. I'm an AWS ambassador, Hashi ambassador, you know, all the kind of stuff. I'm a professional lab mouth. So I'm going to talk about functional testing today. When I say testing, that's what most people think. And there are so many other things you can and should be testing, but I have 45 minutes, so I'm going to focus, or try. Anyway, I generally ad-lib a lot, so we'll see how this goes. Why do we test? And I just realized I have that slide twice. Why do we test? Is it to prevent bugs? Yes and no. Kind of. I'm going to, apologies for this, but I'm going to go a little bit of complexity theory. So when we build systems, they are complex adaptive systems. It's a very, very long way of saying when we make changes, we don't really know what's going to happen. We have ideas, we have theories, but we can't know what's going to happen. And if you don't believe me or this is kind of new, I think we've all been through this. You know, you're working on something, you know, you get to daily stand-up the next day, and yeah, no, but I found something new. It's kind of it's the problem and the fun of software development. It's emergent. You don't know what you're doing until you do it, which is why estimating, another one of my pain points, is pointless. And that's probably also going to piss some people off, which is fantastic. Going from complexity theory, so behaviors of systems, of complex adaptive systems, are an emergent property. You can try and control them, but effectively they happen not 100% by chance, but just because you build something doesn't mean you know what it's going to do. This also means that unintended behaviors are an emergent property because you don't know what's going to happen, which then means that bugs are an emergent property because bugs is effectively just a synonym for unintended behaviors. Bugs are inevitable. You're really not going to get around them. So if testing isn't about preventing bugs in their entirety, what are you actually trying to achieve? Really, for me, it's this. The value of the release you're trying to do, the value of the change you're trying to do is greater than the risk of doing the change. That's all you're trying to really do. You're trying to go, actually putting this change in production is more valuable than the potential risk impact. You can't be sure about this. This is all about confidence. You can never be 100% confident, even with an ego as big as mine. I can never be 100% confident that I've got it right. But really, fundamentally what we're trying to do is how cheaply can you be confident or sufficiently confident that the value of the release is more than the risk? And obviously risk can take many different factors in terms of you break production or unintended, or there's all the damage that comes from that in terms of financial and reputational, and maybe you get smacked across the head because you've released too many bugs into production. There's lots of different kinds of risk in there. Again, just stepping back to complexity theory one last time, I promise, I'll move on. When you look at complex area and then you get tests are these enabling constraints. They allow us to preserve certain behaviors of the system, but they're not guaranteed to exercise the entirety of the system, so you're not going to cover everything, but you're going to cover a lot. Google very eloquently put it like this. The Beyonce rule, if you liked it, you should have put a CI test on it. Google have taken this idea to the extreme with the idea that anyone in the business can make pretty much any change to any system that they want. So upgrading a package, take the log4j thing that happened, right? Google can update that in their one giant monorepo. They are insane. But that can be done by security, and if your system breaks, it is your fault, not theirs. So it's changing where the accountability lies from the person that made the change to the person that owns the system. But fundamentally, Google has probably second to none testing culture, and it enables a lot of the stuff that they do. Again, when we build a system, we have a mental model of how we think the system works, and we have a software model, which is how the system actually works. And testing is an opportunity to refine our mental model to try and bring it closer to the software model. And the closer you are, the quicker you can develop, the less bugs you're going to introduce. This is kind of the basis around, when you onboard onto a new team, you have to understand what's going on, right? So as, you have to build these mental models over time, which is why you get the guys who've worked on the system for 20 years seem to know everything backwards and forwards, and the guy that's been there 2 months is like, what the hell is going on? A really common refrain that I see when people start on the serverless bit is they find that testing just feels really hard. It feels really hard for them to do. They're like, man, it doesn't work the way it used to. You know, I'm starting to do a whole bunch of different things. It's not really working. Like, all of a sudden I need Docker Compose to run like 10 containers on my laptop and it's set on fire. That kind of stuff that you see happening around the track, right? The fundamental problem that all those serverless, you know, Lambda functions and Cloud Run and Azure functions and all that wonderful stuff, although it is technology, serverless as a whole is actually a mindset. It's not just about moving the technology, it's a new paradigm that comes with new ways of working. If you try and apply all the ways you used to do things in like a monolithic on-premise environment to a serverless environment, you're gonna have a bad time, which is what a lot of people do. If you try and do cloud-native development with a pre-cloud testing approach, local dev setup is hellish. You know, working with some enterprises, like, oh, someone's onboarding, cool, all right, well, it might have the laptop set ready to go in 2 weeks. It's like, that's a lot of time. I've worked on teams where we had people joining, pushing to production within an hour of joining. If you get this stuff right, you can move so fast. Testing across multiple services is brittle. This is something people find when they go to microservices, like, oh my God, what is this? How do I get the same level of confidence? And really it comes down to the tests they write are either really hard, they're hard to be impactful because either they're very brittle and really hard to work with, or they're kind of tautological tests that are really not testing anything at all. And they kind of end up in this really weird space where they're like, I don't have any confidence that my system even works when I make a change. And coming back to this serverless as a mindset piece, there's kind of 3 core drivers that led to it, and they all have impacts on the way you test. So these are kind of wider macroeconomic things, but really this is what the cloud, to a large degree, has brought to IT and businesses. So IT, historically, and unfortunately still in some places, is seen as a cost center. You don't want it to be, you want to see it as the innovation center. With that comes a very different level of expectation. You are expected to produce value, not maintain costs, ideally. Generally, we're moving into monoliths to microservices. If you're going down a serverless path, you're going to end up doing microservices. There kind of is no way about it. You know, if you're deploying one Lambda that's God that does everything, think again. And one of the more interesting bits, especially compared to an on-premise world, that it used to be long lead times. Oh, I need a new server setting up, okay. The best case is maybe it goes to the server team that goes and sets something up. The worst case is, oh, we were out of capacity, we're gonna go find a server, come back in 3 months, we might have something for you, right? It's really, really different nowadays. And just on that innovation center point, because if people know me, they know I'd never shut up about the DORA metrics, and I've managed to find a way to fit them in again. So the reality is that nowadays we actually have some statistically verified ways of looking at engineering performance, and it is not velocity. The idea is that you should be able to deliver change frequently, routinely. You don't break things very often, and when you do break things, it's quick to fix. Now, a lot of the time, people come back and go, well, okay, that's all right for the digital natives, the Googles, whatever, blah, blah, blah. The reality is nowadays it's 26% of businesses, 1 in 4. From the survey respondents, so obviously there's going to be a bias there, but you can even see over time, 7 to 2026. This is not about digital natives anymore. This is about table stakes. If you can't do this, you're really going to run into stuff. If you're not moving in this direction, you're really going to start to run into problems. And all of a sudden, the business is going to be like, well, our competitor's innovating so much faster than us. IT, go faster. We've done safe. Now you can go faster, right? We've added more Scrum Masters. We're going to go faster. Not how it works at all. So now on the monolith versus microservices bit, the way it used to be was you used to have a simple arrangement of complex objects. You had virtual machines that did a hell of a lot, and not that many of them. Where it's kind of gone to now, especially in serverless applications, is it's a complex arrangement of simple objects. Everything is easier to reason about in isolation, but instead the complexity has actually moved. It's moved from within the service to the integrations between services. So now when you're trying to test the whole kit and caboodle on a monolith and then you try and do the same in a Lambda function, you're not going to have a good time. Because what you're trying to do is get to the heart of the complexity, and the complexity is actually moved where it is. The test pyramid, everyone's familiar, surely. So this really starts to not apply anymore, because really a lot of that complexity that we used to kind of capture within the unit testing is starting to move to integration testing. Spotify came up with this. It's better. I mean, all models are wrong, some are useful. It starts to actually point to the fact that actually integration testing, unfortunately, because there are caveats on speed, it's starting to get the more important part to do. And really, when you look at this, there are conversations we had about how complex. What are you actually trying to achieve? And this will speak to kind of the years I've spent working on AWS platforms. When you talk about this complex, when you look at Lambda functions, there are kind of two general types that I see. There is AWS Lambda is glue because AWS haven't done something, so you write a Lambda function to do it for them, which is all the time. And really, at this point, you're probably going to have all integration tests and very little implementation detail tests, because your implementation detail really doesn't mean anything anymore, because if you take that code out of AWS, it's useless. So what, you don't have this nice pure domain you're trying to look after. It's about like, well, actually, all I'm trying to do is stitch two AWS services together. There is nothing reusable here. So really, all I need to do is integrate against AWS services. There's not really point trying to configure it so you can test something locally, because what is the point? And I'll get into more about how you can kind of test in AWS a little bit more natively as we go along. The kind of the more interesting one, personally, is with domain logic. We're actually trying to build like a system of some form that services uses, not just makes AWS go quicker. And at this point, you do end up with a mix of integration implementation detail. One of the core things to do when you're doing serverless development is all the side effects. Now, if there's any functional programmers in the room, they'll be very used to talking about side effects as a concept. You want to keep your domain logic, like the business logic of what you're trying to do, that should be kept pure. If there's any Bodo calls or AWS SDK calls anyway in your business logic, you've got a problem. The business logic shouldn't know it's going into AWS or GCP or Azure or a Raspberry Pi you've got sitting on the desk. It really shouldn't know. At the point you've made it so it doesn't know, now I can test locally, because it's just logic that's working. It doesn't understand about any external dependencies in any way. So for my domain logic, I can actually iterate on that very locally, very, very quickly. Then I can independently test that the drivers I've got that are interacting with the cloud vendor work as expected, and then some end-to-end tests to stitch it together. This forces you to structure your code in a particular way. I didn't have enough time to kind of go into a lot of depth with it today, but if you go look at Clean Architecture, there's a book floating around there. If you go have a look at the way they structure code, that's generally how we do it nowadays. Been doing it for a few years. It's worked very well for this. Potentially, how I go on time, and I know I'm stopping everyone from lunch. I might have a chance to show an example, but we'll see how we go. One of these things is when you get to this point, this is a make file that I use. There's a Three Musketeers pattern we use at Contino, which I'm a big proponent of. Effectively, you abstract all your repos with make files to make it wonderful. This is an internal project, the make file from an internal project, and I've abstracted it a little bit and taken some stuff out. But when you look at testing and kind of setting up local development, there's no Docker nonsense in here. There's no setting up databases. There's no orchestrating a million dependencies locally to do things. And I have split my tests up into integration and not integration. So I can very easily run my local tests that will run really fast and check all my domain logic works. And then I can run integration tests and separation. And then for CI, I've got to test everything and report coverage, right? Because when you structure the tests like that to get coverage, you kind of need both running. And I've got some end-to-end stuff that I did with BDD and Behave in this example. But really, I always shudder to think when I see what level of complexity people take on to try and get their testing apparatus set up. Like, okay, now I've got to run Docker, I've got to run local stack. Or I have to kind of actually get on top of the AWS SDK that I'm using to make sure it's actually pointing to the local stack APIs. Okay, all of a sudden it's like, well, it worked on my machine. Yeah, who cares? Like, that's not a valuable thing. You want to be I want it to work in AWS. I want to be confident that it works. And really, the amount of confidence you can get locally is pretty low when it comes down to it. This is a really interesting one I find in serverless, because I've done it, and it's quite a cool thing to do. Like the testing heuristic. Like if you kept all your tests, but deleted all the code, how confident are you that if you wrote new code, it would work? Would you feel confident running that to production? Yes or no? I've gone through the point of actually deleting functions because I hated the way I wrote it initially and rewrote it and pushed that to production. With sufficient testing, like this is the best heuristic I've found in the case of like, okay, well, how do I know that my tests are sufficient? And this is the best thing. Like if you lose your code today, but you got your testing there, you should be able to get close back to production quality very, very, very quickly. Local stack. I've already mentioned it more times than I planned to, but now I'm going to mention it a whole bunch more. AWS I can run locally. I am saved. Now, I've done projects with local stack. I've done a lot with it, to be honest, in the past. It's just not how to do things in the cloud native sense. Yes, you can emulate AWS locally, but why? What actually leads us down the path of test doubles? Because generally in the past it was, yeah, add a test double, add a mock, add a fake, add a stub, run some kind of slimmed down system that kind of responds like the real thing. And they're fundamentally for when orchestrating the dependency is too expensive. Now, what classifies as expensive in here can be the amount of time it takes to substantiate. Maybe it has a high running cost. Maybe you have to talk with other teams to set them up. Like obviously, if you've got a SAP install or something like that, you can't just run up a new SAP install to test against. That's not a realistic thing to do. And I'll talk about some strategies you can use for that as we go on a little bit. But generally in serverless, like, yeah, you're trying to show that actually managing the dependency is more expensive than the test double. Therefore, the test double is worth having. But when you get to serverless, all those things that kind of drove the dependency costs are no longer true. Hard to configure. You've got infrastructure as code. You know, running up a Dynamo table is 20 seconds. Like, it's not that hard to actually configure anymore. High running costs. Most serverless stuff is completely pay-per-use. If you're using it for testing and just leave it alone, it will cost cents a month. Right? When you contrast and compare this about how much a developer costs a day, and I normally use kind of a benchmark of roughly $1,000 a day, any time, like if my developer has to spend 2 minutes on this every day, it's more expensive than just running all the stuff, leaving all the stuff running. And generally in serverless, if you're doing it correctly with autonomous teams and everything else, you don't generally have dependencies on other teams. You have empowered teams who are able to take control of this for themselves. We all know that handoffs are where productivity goes to die. So, you know, generally, if you find the empowered teams thing really hard to do, no technology is going to save you. You need to revisit how you've actually structured the organization. Just one of those things. So one of the common refrains, and I even get this internally, and I've had this debate so many times, which is one of the reasons for writing this talk, because I got sick of writing the same thing in Slack every week. People always like, oh, but then I want to run a local test, and oh, it takes a while to stand up the infrastructure, and I don't want to do that every time I run my tests. I said, who said that you're standing up the infrastructure every single time you run your test suite? That's insane. Why would you do that? This is just some Python code that I've used, and I don't want to think how many repos now, that effectively just jumps in and runs Terraform init, Terraform approve, Terraform apply, and Terraform destroy. What you'll notice is there is a environment variable escape hatch that if I set that environment variable to local, I can just stand up the Terraform once outside of my test suite, and it will be long-lived. It's not going to get automatically torn down, so I can live stuff up for the whole day and then pull it down at the end of the day. So then when I'm actually running these tests, my data layer and all that kind of stuff is long-lived. So I'm not having to wait every time for Terraform or CloudFormation or what have you to do things. Instead, for CI, it defaults to running new stuff up. And CI, you want under 10 minutes. Like, don't overly stress about, my CI job took more than 2 minutes. Now I'm losing productivity. It's not a worthwhile optimization, kind of beyond 10. That seems to be the general rule of thumb. And generally with Terraform and CloudFormation, most stuff you can rig up in 2 minutes and then have all your tests run on top. This was often an example that, something I did for a client back in the UK with AWS config, because some AWS stuff, like DynamoDB, you can build up, it's yours, you can deal with it. Something like AWS config, and this is again kind of working at the platform level, I was trying to build a Lambda function that aggregated certain config rules across the entire organization, reported kind of a classification of resources. Now, AWS config will give me different responses every single day because people change things, and I can't control that. I can't tell everyone, no, stop, you can't deploy resources because I need to test my thing. So this kind of comes from the React testing house of snapshot testing. So people have done, have unfortunately had to do front-end work, which I honestly hate. Then you will have come across snapshot testing in here. Within Python, there's a library called Placebo that allows you to effectively, you call AWS once, and it stores the response. So next time you run your test, it replays that response back to you. This is higher fidelity than local stack because it's actually coming from AWS. And it allows you to actually test things properly. So I can, verify that my function running actually does, it does give me the right responses. And has anyone ever configured local stack with a Python helper? Because it's about 5 times more code than that. just to make it work. This is really, really simple. They get committed to get everyone's working from the same thing. Really, really, really simple to do. If you can't control, if you can't orchestrate the dependency properly, then you can just capture the responses. You can refresh it occasionally, but don't change your code and try and do the refresh at the same time. It's one or the other. There are better things. There are more cloud-native things. There are things far more in line with what we want to do. AWS themselves have released SAM Accelerate. Serverless Framework has a similar thing, where instead, as you make code changes, they are live streamed into AWS. You get full fidelity testing at speed, and you get true cloud-native testing. When you kind of get down to it, and as you actually properly secure your cloud environments, and you actually have production-like infrastructure, running as you in the account will not allow you to test anymore, because data should be locked away. KMS keys, you should not have access. I'll make the point that generally most environments are not set up to this level, but they should be. But fundamentally, you want to be actually assuming the principle of the Lambda function or equivalent when you're actually doing this testing, because it actually tells you what's actually going to happen. You know, you'd actually, if you try and do all this local stack testing, or even just testing locally against AWS APIs or GCP APIs or what have you, if your security matures to a certain point, it's all going to break. And it should break, because the reality is you should be testing against production-like infrastructure. Production-like infrastructure shouldn't be allowing you to get into all the databases and pull stuff out as willy-nilly to check things have gone where they should go, right? So coming back to this refinement piece that I talked about before, when you're testing against local stack, you are testing how your system works in local stack, and you're bringing your mental model closer in tune with that, not actually with where it's actually going to be running in production. For example, and local stack fixed this ages ago, but when I was using it, I found that the DynamoDB types were a lot looser. So what was working in local stack, when I went to AWS, was being rejected by the API. Now, you know, that in and of itself maybe lost me 10 minutes of time, but 10 minutes of time multiplied by the amount of devs hitting all these random little edge cases and all those kind of things doesn't really work. And also when you start to look at local stack, yeah, kind of the basics are there. And you've got like the services enough to wet your whistle. You can get in like, okay, Lambda's there, Dynamo's there, cool, I can start working. Now I want to kind of, I have X-Ray in there, and I have a whole bunch of other things in here. Looks like, cool, pay us. No, what? This was all about saving costs against AWS. What are you telling me I now have to pay a license for every single developer? Are you insane? And fundamentally, these AWS costs are so minuscule. Like, your local stack cost is going to massively outweigh your cloud bill. And this is insane. It's kind of on the last kind of rant I'm going to go on. Again, this comes from people, and it's not that these approaches were wrong at the time. They came from a certain time, certain place, certain paradigm, and certain ways of working, and they made a lot of sense. The point is that when you go to serverless, that you need to reevaluate how you do things. One of these things is, I mean, I've hardly ever used a debugger. I'm really bad with them, but you know, a lot of the time people get used to being able to attach a debugger to their running code so they can look at the variables as they're going and all that kind of stuff. And then they get to this point, like, how do I attach my debugger to the Lambda functions? You can't. You know, people used to do what seems in retrospect insane, where they'd like go onto a production system, attach a debugger to a running Java process to have a look at what's going on. You know, in my mind, that's insane, but I can also understand why they did it at the time. But nowadays, you know, that's not an option, and you shouldn't be annoyed that's not an option, but some people do get annoyed. You know, this is just an absolute classic meme within the space, right? The thing is, it used to be lauded at as being ridiculous, when in reality, it's actually the case of how you should be doing things for a large part. You know, we always come out with the adage that, you know, code is read 10 more times than it's written. The reality is it's run in production thousands to millions of times for every time it's written for any code that's doing a lot of stuff. So really, where you need to focus your efforts is in how do I understand when stuff breaks in production, more so than how do I fix stuff locally. One of the things that I do a lot with teams is beginning with the end in mind. And this is trying to bring SRE principles in, just kind of service level objectives, not the other 6. But just looking at how can I use service level objectives to define what I'm doing. You kind of got, whenever you're kind of developing anything, really, and these are 2 questions that for every single feature should be asked, is how will I know my feature is broken, and that gives you your mean time to identification, and how will I determine why it's broken, which is your mean time to recovery. If on every pull request review, if you're not asking these questions, you're going to end up pushing code which isn't operationally sound, maybe functionally correct, but when it blows up, you're going to be really sorry at the end, right? For me, you should be looking at this one first. Before you actually develop the feature, you should be building the apparatus that allows you to understand your feature is broken. And then second, you can determine why it's broken. So SLAs, SLAs, I talk about these way too much, but for anyone that's not familiar, service level SLIs, service level indicators, defines your success and failure. So for the feature, how can I measure that it was successful or it failed in production? What does that actually look like? Service level objective then defines what an acceptable failure frequency is. So, for every 1,000 requests, one's allowed to fail. Something like that, expressed as percentages. I'm sure you've kind of all seen SLAs floating around. And then an SLA is a contractual obligation, defines a penalty for every time you actually fall underneath that failure goal. Reality, most systems, you can just stop at SLOs, especially for internal systems. One thing I'm going to get into here, which is just something that always shits me, is an SLO written in Confluence doesn't mean anything at all. I call them Schrodinger's SLOs because no one knows whether it's alive or dead. I hate how often I see systems where people don't know whether the system's alive or dead. They're just kind of hoping it is. I'm not going to say anything about putting them in a box with poison and waiting for a timer. One thing that we've done, and this is going open source, this is not a sales pitch, please don't take it as one, was we built at Contino, I built this for a client in the UK, a way of dashboarding things in AWS that was SLO focused, that we kept it's all serverless, all very extensible. But this, on the team I built this with, the first thing we did for every new feature was add it to the SLO dashboard before we started working on the feature. You can see some at the bottom around patching, compliance testing, and backups and stuff like that. I built, the backups was one I did just before I left, where we were rolling out a new backup solution. So the first thing I did was roll out, and this was where the config bit came in as well, the ability to understand how many instances are currently outside of backup plans, how many don't have active backups, with the idea that as I build the backup solution and roll it out, and this is across 500 AWS accounts, so you can understand why I'm trying to track these numbers, because you can't possibly hold that in your head. But I wanted to be able to show, as we roll it out, that these numbers going down. Because otherwise, you roll out a backup solution, and this is a classic thing. We built the tool. Is anyone using the tool? I don't know. Okay, why'd you build it? And really, fundamentally, when you're doing this cloud-native development and talking about testing and getting into debugging, you should be trying to debug your development with the same tools you're going to use to debug it in production. Because otherwise, and this is another rant of mine, debug logs, why do they exist? Why do they ever get committed to mainline? Because you get them in production, you're like, oh, I'll be able to figure this out if I had the debug logs. Great, what are you going to do about it now? If you wrote these logs to understand things in development, you should be turning them on in production as well. Yeah, it's just a rant of mine. Because again, going back in time, you used to be able to switch on debug logs by changing an environment variable or something like that. You can't really do that anymore, and even if you can, transient issues that you see that have disappeared and you really wish you had that log data, oh, it's gone. Oh, well, too bad, right? Really, you get down to it and you end up with, be able to use X-Ray and CloudWatch, Grafana, Prometheus, all these kind of tools in production and, Cloud Operations Suite and Azure Logic Monitor, you apply the tools, synonyms for whatever cloud you use. But really, if you can't use these to figure out why your development's not working, how are you going to use them to figure out that production's not working? Debugger and local tools and that kind of stuff, you're not going to have them when you really need them. So why are you focusing on becoming really strong with them? Like when you look at Honeycomb and observability, which I suggest everyone do, they instrument everything and they use Honeycomb for all their kind of needs. It allows you to actually just, your code's going to be running in production for much longer than it takes you to write it. You should be focusing on that. And when you get good with the production tools, they're not going to slow down your development cycles by using these things. But it makes a lot more sense than trying to use a debugger locally and then getting stuck in production. So I'm actually running ahead of time, which is nice, unusual for me, and I know I'm keeping everyone from lunch, so, go figure. But I just wanted to kind of revisit back revisit back on the 3 key lessons. The one, testing period is anti-pattern. There's the testing honeycomb that Spotify have. It's better. I still think as an industry we can do better than that. Emulating the cloud is a recipe for disappointment. I hope any of you that are using local stack or equivalents today, maybe I might get lucky and some of you might revisit that decision next week. I understand that it's investment and everything else, and we're going to change the way we test, makes a product owner cry because they're not getting any features, but you need that time to actually invest in, paying down tech debt. And to be honest, if you're using local stack, I would classify that as technical debt nowadays. And last is testing doesn't stop when code hits production. You really, that's where you should be focusing for, because that's where your code delivers value and where breaking actually becomes a problem. So yeah, fundamentally look at what tools are in the cloud that you can use to understand your production code, use those for your development code at the same time. That was all I had, so hopefully there's some questions.
Like yet? Yes, I am. Have we got any questions? First of all, Josh, I love your brutally honest approach. It is fantastic. It's very real. I just wanted to throw that out there. Questions? Anyone hand up? Oh, sorry.
Sorry. Yeah, so I guess if you need to keep CI tests fast, that requires that you're able to kind of spin up an ephemeral stack and then tear it down in a matter of minutes. Like, what patterns would you use when you have like a hybrid architecture where you kind of necessarily have 1 or 2 serverful resources, say AWS Elasticsearch, for example?
Yeah, at that point, you've got to make like a trade-off at some point for going, well, the cost of keeping it running versus the time saving. You should be able to kind of, when I come back to that kind of $1,000 a day, you can run the data and go, it's going to be more effective to do it one way or the other. But I think it would be try and get the data together to go, running Elasticsearch is going to cost us this much if we just leave it on. Okay, well, is that worth the speed up in development time for that? Like, it comes down to, you've got to make trade-offs. You just want to make the cheapest trade-off, whatever that is. But yeah, Elasticsearch is a pain. And it's expensive as well, so it's a hard one. And in that case, you might want to actually eat the CI run or, yeah, generally have some kind of mocked version of Elasticsearch. I'm not saying you can't mock. I'm just saying don't default to it. If it's going to be cheaper and you're going to get the fidelity you want, then mock away. But just, it should be not the default position. It should be, yeah, the other ones are too expensive. We need to go down this path.
Fantastic. Next one. Alrighty, hecklers in the front audience. Now, I am told you are here to heckle. So, have we got any heckling? No. Right. All right, guys.
So disappointed.
Looks like I'm going to get all the books. So, joking. Seriously, if we've got any questions, guys, please put your hand up. Fantastic. Thank you.
What's your opinion on sort of Docker versus Lambda? So, running native Lambdas versus running Docker containers or Docker serverless, or
I mean, with contain,
it's another level of abstraction, but it's also another level of testability.
Yeah, I like Docker using Docker images, Docker containers for local development to try and get some standardization on environments. But if you're throwing them into production, be aware that you're accepting a higher level of accountability when it comes to your security posture in terms of managing the containers, fixing vulnerabilities, all that kind of stuff. Like, when you're in when you're running Lambda without containers, AWS fix stuff for you underneath. If you've got a container strategy and everything else, and you've got all that kind of stuff in-house, because maybe you've got some Kubernetes somewhere else and whatever, and you can kind of piggyback on that. But I still generally try and go with native Lambda where possible, because it's less work for me to do from a security perspective. Operationally, it's not fantastically different, but still, Docker, you're pulling extra packages that you have to rotate and fix the CVEs for. I think Sheldon had one.
Awesome.
One repo, one function, put them all in a mono repo.
Mono repo. One function, one repo would just, my God, you'd hit your GitHub limits in about a week. Like, I always think start with mono repo because it's easier. and you can wait till you hit a scaling point. You're like, actually, multi-repo will work for us. Like normally when I've started a multi-repo before, and it's like, okay, well now we need to share this kind of package of types around between the repos. Now we've got to figure all that out. And it's like, now we've got to push a dependency out. We've got to pull dependency version. Dependencies like, oh, what's the value in doing this? Oh, we have multiple repos. Yeah, but what's the value of multiple repos? Like, if you're working in vertical slice and you have your code set up properly, that you shouldn't be hitting like merge conflicts all the time or anything like that, and at least it keeps your code more consistent more easily. I've kind of gone back and forth on this over the years, but at the moment I just go monorepo until I feel the pain. Especially if you do clean architecture, like you end up with one code base that you kind of change the entry points for to do different Lambda functions. So you end up with just kind of one blob of code that you deploy in different kind of configurations to do things. Which is generally a lot easier from a packaging point of view. It makes stuff a lot simpler.
Well done, because I didn't know what you were going to answer to my why, because I am not sure what a monorepo is, if I'm honest, guys. So sorry for throwing you a little bit for six there.
No, go for it.
Down the back, give me a sec.
Hey, Sam.
Have you applied these techniques in a Kubernetes environment?
Yeah, I mean, it's not fundamentally all that different. It depends on how much managed services you're running and all that kind of stuff, but effectively I think the patterns still apply. Like when I did some work for one of the mining companies in town a few years ago, and we built it and we deployed it into Lambda and ECS from the same code base. We just had to change stuff on the edge, and it was the same approach for both. There's nothing, like effectively, your code to a large degree really shouldn't understand where the hell it's being deployed. And you should be trying to take those changes and push them right out to the far edge of your code. Again, clean architecture helps a lot with this, but yeah, running in Kubernetes or not, the same principles I think still apply of just try and use the cloud as much as possible and stop trying to run like a Postgres database locally or whatever. Like you shouldn't need to. I mean, Postgres is a little bit different because it's such a standard, like stable platform that the emulation is generally very, very high fidelity, but still like, you know, try and figure out what you can do cheapest. And generally developer time is the big one for cheap. Family zone, I know sometimes you guys have different ideas on that, but most of us it's developer time. You guys have scale problems that all of us wish we had, so it changes the needle sometimes.
Alrighty, we can probably fit one more question in if we have it. Awesome. Thanks, guys.
Do you kind of have any thoughts on what might be good kinds of production tests to do and maybe sort of organizational pushback on doing that kind of thing?
I mean, yeah, organizations really always push back on testing. I think it is that I really like the service level objective stuff. I really like being able to understand how my feature is supposed to work and how I'm going to track how that feature is working. And having just that really quick feedback, I can see I'm burning error budgets, so something's gone wrong. I do think the SRE, looking at SRE for how to run stuff in production is probably the way to go, but I would say that's SRE as in like the Google books, not what a lot of vendors sell today, because I've had so many arguments on redefining it at enterprises where GSI's got in first, and they're like, oh, and it's rebadged ITIL build and run. That's not what SRE is. I think in production it's pretty much like, how do I know something's broken is the big thing. And service level objectives are probably the kind of the becoming dominant way of doing that. Like there is the classic monitoring of my CPU's spiking, send an alert, and it's like, no, you need the kind of business impact level metrics to understand that customers are being impacted because you measure from the customer. And then CPU spiking, useful diagnostic metric when you're in kind of debug mode, but you shouldn't be alerting on that. You should be alerting on, you know, we're hitting so many 500 responses are spiking, something's gone wrong on our API, cool, let's go and fix that. Again, observability and Honeycomb is the big kind of, I think it's the big paradigm shift that's coming. Where you've got like high cardinality events. Again, I definitely do not have time to get into that in any great detail, but I can afterwards if you'd like. I'm more than happy to.
100%. Look, guys, that's probably time, Josh, but a big round of applause. That was unreal. Now, just a few friendly reminders. Lunch will be immediately served once you leave this door. Now, you can go the north or the south, or you can just duck over in front of the theatre room. There's going to be food sort of everywhere, basically, from what I'm reading here. Lunchtime sessions will commence at 2:35 in the theatre. That's definitely a typo, at 1:35 in the theatre. and both the river rooms. Note, do not do what I did before and eat your apple because you will get in trouble in there. Attendees, there will also be breakout sessions that will commence again at 2:15. Definitely 2:15. And I've got one in here with a wonderful, wonderful lady, and she will be talking about standing on the standing on the shoulder of giants, the next great generation in technology. So on that note, thank you again, Josh. Thank you, hecklers and everybody. Have a great lunch.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, You need a professional bodyguard delivered to your door in less than half an hour? You got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster. You know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
Hey, bigger customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey, friends. I'm Scott Hanselman, and I was told to give you a tour of my office. Nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Henselman's troop.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink Beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, you Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Run is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality, everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. but I really needed to wind down before bed. So I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Oh my chocolate!
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster. You know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Oh, my chocolate.
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Oh, my chocolate.
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Henselman's troop.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God,
at
this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the ping, no matter the client, no matter where I was working, it always was a ping background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so ping beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place, because we have got all the training materials, right people, and right opportunities. Whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's troop.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Henselman's troop.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the ping, no matter the client, no matter where I was working, it always was a ping background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so ping beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking at
This is like my dream come true. I always wanted to join Scott Henselman's troop.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster. You know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
And I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the ping, no matter the client, no matter where I was working, it always was a ping background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so ping beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, you go first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Drum roll, please, if we can grab our seats. All right, I'm really excited about this. Our next speaker, Gia Kanatsu, which I've probably pronounced wrong, but I am going to make her my new best friend because she is not only an early in career solution architect at Microsoft, an immigrant from Thailand, an endurance athlete, a tech optimizer, a STEM advocate, a TEDx speaker, a multi-award winner, a multi-award winner of the WIT WA 2019, a NASA Space App Challenge, Energy Hack, Transport Hack WA, and the UWA Innovation Challenge. Gia empowers her customers in environment and sustainability to do more with data and AI. And you will often also find her volunteering. So over to Gia because you are the guru.
Thank you, Emma. Okay, how is our energy level today? Good? Woo! Okay, if you feel like you're just gonna sleep, that's okay. It's gonna be like bang, 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 and then we leave the room, okay? Now, good afternoon, everyone. Thank you for coming into my talk for the next 20 minutes. I'm so grateful for you to be here. Before we begin, I would like to acknowledge our sponsor. Without them, wouldn't be possible for us to be here today. Now, whether you are a leader by position or a leader by title, by position or by title or by spirit, this one is for you. The purpose of my talk today is to share my experience and observation from junior perspective. Junior who has not just survived but thrived in technology industry because of all the great giants that have lifted me up and stand on their shoulders. And I will distill their behaviors, like great behaviors of my giants based on true story and outline immediate actions for you so that you know that, hey, helping early in career is actually an act. You know, it's not a now, you don't have to become a mentor, sponsor, and advocate. You just simply act. And I hope that collectively we can keep producing the next great generation of leaders in our industry. Hi there, I'm Gia. I'm an early career myself. As you said, I work at Microsoft as an associate cloud solution architect. Outside of all the things that Emma didn't say, I am also building a community of early in career for Microsoft Australia and New Zealand as well. If you see this, you gotta appreciate my drawing, come on. This is the gingerbread man, but actually it's the early in career, okay? And outside of the job that I get paid to do, I also do a lot of community work. I teach and upskill digital skill for other people, specifically disadvantaged students or like the minority group of people. Now, how did I get here in the first place? I'm going to take you, and we're gonna turn back time together before I joined the technical workforce. All right, the journey has not yet begun. There I stood with a piece of paper and a koala in my hand, smiling at a photographer, walked out from graduation with some basic skill in ordinary but limited reality, right? And I was just hoping for the best for my future. After mucking around for a little bit, I then discovered this unfamiliar place called the corporate jungle. As I entered the corporate jungle, can somebody take this? Because it was supposed to do like speaker pose. As I entered the corporate jungle, that sticky man, not sticky man, white stick man is me, by the way. As I entered corporate jungle, I first encountered this murky water. I was asked to be untruthful to my values so I could go through shortcuts. And then I faced this acid rain of self-doubt and not so good enough syndrome, right? It burned my skin and soul. And when I thought that I was gonna get better on the high, guess what? The world's biggest pandemic arrived. We all sent down to this underground bunker. Don't know what happened there, but it was like spiral down. So hard to climb up. Anyway, eventually I climbed up out of there, and I faced the biggest spider of my life, which signified the new career change. So I changed my career. At first, new job looks terrifying, but actually, it was not as terrifying. And did you know that spider, they are actually friendly. They look terrifying, but they are friendly. That's why. And with new job came new terrain, right? I was exposed out there where trolls could attack me, and I thought I was gonna die, but I've survived, and despite it all, the journey still continued. But I didn't go through this risky and perilous situation by myself. Now, in the mainstream media, you usually see this. Why old wizards love mentoring and advocating for younger people, right? But mentors and advocates take many forms, from beautiful maids to kung fu instructor to the blue robot cats of the 22nd century. Don't know if you know Doraemon, but I grew up with Doraemon. I'm from Thailand. I grew up with Doraemon. To big and friendly giant. And there enter the giant throughout the journey, right, of risky and perilous situation. Now, the giants that I met, they showed me the way, they lifted me up, they leveraged their height so I could see the path and possibility in front of me. They provided practical training, right, profound wisdom, and they pushed me and they challenged me to fight in the new terrain. They helped me build grit and self-confidence. Now, for us here today, what I'm gonna do, I'm gonna highlight each of these giants' impacts that they have on me and behaviors that worth modeling from, okay? Now, first giant, Jason Yao. Jason's not in the room today, and he doesn't work at Microsoft, by the way. Jason was the first giant when I was trying to figure out what am I doing in technology, because tech is so vast, no idea what I'm doing. I thought I was not gonna go back and see Jason Yao again because our first conversation was so confronting. I asked, can you help me get a job? I wanted to be an IT or software consultant. He turned around and he said, no, you don't want to be an IT consultant. He said that. No, and he said, you don't want to be an IT consultant because you don't know what you want to do. You said that because you don't know what you want to do. You gotta admit it. And I was like, what? Excuse me? How dare you burst my bubble? How dare you tell me what I want and what I don't want? So he said, okay, before we come back and meet each other again, you gotta list out, okay, 100 jobs in technology and do your resume as if it were to be in the year of 2050 and come back and talk to me. And I was like, 2050, 30 years from then. Okay, well, I'm not gonna do that. But guess what? I did it. I did the resume, right? List out all the jobs. I went through that exercise and really do the research and trying to understand what it means. And I was like, hey, Jason was right. I didn't want to be an IT consultant. I said that because everybody at UWA said they want to be an IT consultant. All my peers said they want to be a consultant. Now, without that exercise, I wouldn't break free from the traditional thinking, right? Wouldn't think for myself. What we can learn or distill from Jason's story here is that you, as a leader of today, you have to challenge the initial belief of your junior. So you help them disrupt their traditional way of thinking that might not be true. And then they can think for themselves or develop critical thinking skills. Now, my next giant is Kirsten Gergen. Of course, I know her name, but anyways, it was hard to get a job in tech at first, like in tech in Australia, especially being an international student. So KG helped me get my first job in tech, right? She was so well connected. She loved connecting people together. She pushed so hard to actually land me the first job at the Cisco partner company. I get to test what it's like to work in tech, right? And that opportunity was so important to me to learn that, hey, employment was a two-way street. As much as I want to be employed, I also have to evaluate my employer value as well. So I later left that partner company because our value didn't align. But what we can learn from KG here is leverage your extensive network to help your junior land that opportunity, to help your junior get their first job or wherever they want to go, right? If you know somebody that you can connect them with, do that. Now, oh my God, she's not here anymore. What? Anyway, so my third giant is Michelle Sanford. I actually could make the whole day conference about Michelle, but I'm not going to do that. I only have 20 minutes. So Michelle let me borrow her belief in me. When I landed my job, when I landed myself in Microsoft, it was about 8 months in. I was a grad, right? I knew nothing about Power Apps. If you don't know Power Apps, it's a product Microsoft owns. Power Apps, and I knew nothing about running a workshop. I knew nothing about anything, literally, because I was still learning the world of Microsoft. And Michelle volunteered me, right, to run a one-day workshop for International Women's Day. And we invite a lot of women from not-for-profit organizations to come and learn Power Apps. Surely you say, Gia, you're not the only person at Microsoft. There gotta be other people. She walked up to me and she's like, Gia, you are the last person standing. I believe you can do this. Oh, there you go, Michelle, hello. And I was so stressed out, right? I was like, to be honest, I was scared as shit out of me, excuse my language. But I only have 3 days to learn the Power Apps and write up the script, prepare the environment, everything. I was like, what am I doing? And Michelle actually went to another party. So thanks, Michelle. But anyways, I was so stressed. But in the end, everything went well. Thank you very much. Because without that opportunity, I wouldn't know that, hey, an early in career like me, just landed 8 weeks into Microsoft, can actually make an impact already, right? So what we can learn from Michelle here is you have to give your junior challenges for them to solve, right? So they can build up their confidence as they learn to handle and overcome those challenges. All right. Is she in the room? Hello? Hi, Antoinette. So Antoinette is my fourth giant. So I would feel lost in the world pandemic without Antoinette. I joined Microsoft as a grad, right? And we were supposed to go to this Canada. They flew us to be together, mucking around, trying to find out how to do stuff in corporate jungle and meet Microsoft executives. And potentially, this is what I was thinking. They probably installed chip in our brain so that, we all get brainwashed and oh my God, Microsoft. Anyway, that did not happen. That did not happen because everything got canceled a week before we flew. Remember at that time? Pardon? Thanks. Anyways, I was like, oh my God, did not happen because the world, remember that time, weird time, where we went into the lockdown and everything went virtual? Remember, it was a weird time. So we just what happened? anyways, unfortunately, a lot of people in the younger workforce, they feel lost in this transition because they haven't grasped the concept of work yet. They're still learning their job, and also they have to learn a new way of being and doing. So I felt lost in that transition too. Now, during lockdown, I was going through family member loss and some issues. So I kind of grounded my self-worth in work. I do nothing else. I only work, right? I only work. And I thought it was everything I had because, hey, I deserve a spot at Microsoft, therefore I have to show this to everybody. But actually, it's not really true. Anyways, Antoinette came in. She led me out of that downward bunker spiral you saw in the beginning. Anto been working at Microsoft for a while. She knows ins and outs and everything. She noticed my Garmin. And she's like, oh, you run? I said, yeah. We start running together. We started training for half Ironman together. And during those training, right, she would also coach me to navigate difficult work situations or, show me the bigger picture of Microsoft of hey, this is what we have we did it before the pandemic arrived, or give me harsh feedback, not harsh, honest feedback. There you go, honest feedback. Sorry, honest feedback. And until one day, I just realized that, oh my God, everybody around me said, hey, Gia, you've been brainwashed by Microsoft, even my parents. And I actually truly believe that I found my place at Microsoft and I feel belong and I love this company. Now, this is not about Microsoft talk, but I'm just going to keep pushing on just to let you know that I meet really great people there. And what we can learn from Antoinette here is that you have to connect with your junior outside of work so that, you form that friendship and you create that sense of belonging for them. Because sometimes it's a really lonely place, the corporate jungle. My next giant. Hello, Jonathan. Hi, Jonathan. So, Jonathan Wade, when I decided to change my career from account management into cloud solution architect, I don't know if you know, but the two careers this two separate way. It doesn't go the same. It's super technical and super not technical. So many people ask me, how did you do that within a year at Microsoft? I wouldn't be able to do that without Jonathan Wade. So Jonathan is our director of Microsoft Azure in Australia and New Zealand. He believes in diversity of thoughts. And you know how solution architect, they always hire 10, 15 years experienced people to come into the role. Resulted in similar way of thinking. They went to the same school, read the same textbooks. Sorry, the same textbook. English is my second language. The same textbook. And basically similar way of thinking. And he was like, no, we're gonna give different people that has different year of experience to come into the role. And then we're gonna get people with different backgrounds as well. It doesn't matter if they have technical experience, it's okay. We're gonna do this associate cloud solution architect program. So he was pushing hard for that. And without Jonathan, I wouldn't be in the role that I am today. So thank you very much. What we can learn from Jonathan here is that if you have the privilege of any source, right, use your privilege to create the space and time for diversity and inclusion to emerge. My 6 and 7 giants. Anyways, there are two key people that helped me actually get into the role as well. Michael and Morgan. When I actually saw the solution architect role come up, I called Michael, which is my ex-boss now. I said, hey, Michael, I saw this opportunity of a lifetime. I applied. I didn't really tell them. I just told him I applied. Please support me. Michael looked at me with disbelief, on Teams call, and he was like, how dare you? That was on his face, because he has to go through recruitment and everything, right? But he did not sabotage my career at all. He actually supported me throughout until I was a successful candidate. And when I got the offer of the solution architect, I saw my number went up, it got bumped up. And I was like, oh, that must be something wrong. I called Morgan and I say, hey, Morgan, I have no experience. Just need to make sure that this is the right number. And it's like, no. Because of your impact that you create in the last year at Microsoft, this is a fair compensation for you. And I was like, oh, really? Thank you very much. Thank you for looking after me. And what we can learn from these two giants is that first, you have to invest in the growth and the development of your junior. And secondly, you must fight for fair compensation for them in relation to the ability to create impact, not because of their years of experience. Now, my 8th giant, Daniela's Matthew. Remember the associate class solution architect that Jonathan was trying to push for? Daniela was on the ground doing the work, set up the program, set up the structure around it so that the associates that come in later know what they're doing. And there are about 4 associates in our business right now. We spend less time mucking around. They're trying to learn technical stuff. We know there's a path in front of us and what we need to do because Daniela's been there before. What we can learn from Daniela here is that if possible, pave the path for them. Pave the path for your junior. Make it easier for them to follow. Don't make it hard for them, career in itself is just already hard. Now, Rivage. So, Rivage, I had to learn a lot of technical concept. First 6 months, oh my God, my brain was swollen. And what I really appreciate about Rivage is that he would spend hours and hours learning the concept that he doesn't know with me, like data governance, just to make sure that, hey, I can actually develop my skills, right? And I still have so much to learn, so much to improve, but I am now more confident in my technical skill than a year ago, and that would not be possible without Rivage. Now, my last giant I promise, is it the last one? Oh, sorry, no. What we can learn from Rivage here, sorry, we have to have the technical or domain expertise and be willing to learn and grow with your junior, okay? Because technology is an ever-increasing landscape. Now, my last giant, Sergio. So, remember, I don't know how many people have done the conferences, live demo and stuff. Shit always go wrong. Things doesn't work, right? You probably have seen it so many times today. That happened to me too. I was just so stressed out and oh my God, cannot even talk properly. And one day I actually delivered my first workshop and I got the feedback. In the feedback form it say, we spent a lot of money at Microsoft. How dare you send a junior person to teach us? She wasted our time. And I was like, wow, that deflated me because I actually spent a lot of effort on that. But Sergio came in and was like, hey, I have extensive experience in this. Let's run the workshop together. So we do so many together. Until today, I can actually run my live demos. I can do conference talk. I can do whatever things that I need to stand up in front of people and talk. And that would not be possible without Sergio. So what we can learn from Sergio here is, hey, if they have not done it before, let them fly with you for a while, right? Let them fly with you until they can fly solo. Now, out of all of this, what I noticed, the insights of all the giants is that it's not just, their peers. It's not just people in the team. It takes a village. It's not just one person. You might say, there's so many giants. That's the point, because you have so many people that you can leverage and get the help from. And it has to go up to the manager and the sponsor level as well, right? Okay. Promise, last couple of slides. Tick, tick, tick. We know it's hard to start out. I don't have to say this, but we all know that it's hard to start out. Hitting the ground running, catching up with the people that have been in the industry for a while, right? And the expectation to solve the complex problems are ever increasing in technology. Now, if we don't have or provide without proper support or close support for your junior, it's like they are going through this loss in transition in their growth and transformation. Without loss, it's like this. You're sending them out to slay the dragon in the first episode. You are setting them up for failure, right? But it doesn't have to be like that. It should be learning from the wise and shadowing the experienced one, because they've been there before. Now, I'm gonna skip it, but you know what? If you wanna take photo, take the photo. So you might ask me okay, look for potential, because not everybody is fully developed, right? Not everybody. So look for potential. Now, there's no greater gift than the gift of growth. What I want you to do now, pull out your phone, right now, pull out your phone. Come on, pull out your phone, pull out your phone. Go to your to-do list of choice. And I'm sure when you were listening to me talking just now, right? someone's name pops up, write the name of that junior person down. Write that name down, your to-do list of choice, and next to that person, and if you are junior, write the name of the person that you want to, reach out to, okay? Next to that person name for the later in career, write this down. I will help you slay the dragon in the corporate jungle. Okay, if you're a junior, say, I need your help slaying the dragon. Monday comes, the name that you wrote down, reach out to them. Set up one-on-one, coffee, catch up, bubble tea, whatever, and let them know that you're here, that you need help for junior, that you can help them, offer that help. When they ask for help, listen carefully, okay? And I understand we cannot take everybody on our shoulder, right? Find the right junior that you can connect and vibe with. It's like dating app. It takes a while. It takes sorry, it's wrong context, but it's relationship has to take two ways. It takes two ways. So this person Monday might not be the person you can connect with. That's okay. Next month you do it again. Keep finding the person that you can, connect with. All right, last slides. Season finale. Today I'm still in the journey in the corporate jungle, but I am at the full capacity. I owe all the giants the confidence that I now have in myself. Without them, I wouldn't turn out to be so awesome. So as I stand on the shoulder of giants and look at the path in front of me, I know that I'm ready to take on new quests, and continue to make my mark in this terrain and beyond. Thank you very much. That's okay. That is a summary. If anybody wants to take the photos, it's just too wordy, but
I was about to say, can you leave that up so I can take a photo too, please?
Okay, yes.
Gia, that was fantastic. As always, I will come see you a little bit later and probably bug you on a few things. Just a heads up, guys, we've got afternoon tea. So that's in the Riverside Foyer or the North and South. And just a friendly reminder, please be in the theatre by 4:05 for the lock note. Thank you, and well done again, Gia.
Thank you.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the Ultimate Keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.